Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Ladies and gentlemen, distinguished guests, and honored participants, good morning.
PN Veteran Jakarta, Dr. Antar Venus, Master of Commerce, Honorable to RINA Executive, Mr. Chris Boyd, Honorable to Chair of International Steering Committee, Dr. Wiwin Sulistewati, STMT, Honorable to Chair of Local Organizing Committee, Fahri Akbar Ayub, STMN PhD. Honorable to Kenneth Speaker of Australian Maritime College, Prof. Martin Reynoldsson, Honorable to Kenneth Speaker of Institut Teknologi Sepuluh Nopember, Dr. Insinyur Setyo Nugroho, and honorable to all the participants and of course all invited guests. Welcome to the 8th International Conference on Ship and Offshore Technology 2023 with the theme Ship Safety and Energy Efficiency.
I am Faiz Shakir and my partner,
Happy Nabila, your Master of Ceremonies, and it is truly an honor to guide you through this 8th International Conference on Ship and Offshore Technology 2023.
the Indonesian International Conference on Ship and Offshore Technology, are more popularly known as ICSOT Indonesia, is a biennial conference and jointly organized by Indonesian University and the Royal Institution of Naval Architects. Before we start this event, let's pray together. Pray, begin. Pray, finish.
Next, I would like to read today's agenda. The first is registration and preparation, opening ceremony, national anthem, welcome speech from chairperson of ICSOT, welcome speech from rector, welcome speech from RINA Executive, cafe break, keynote speech, lunch break, parallel season day 1, cafe break, parallel season day 1, and closing day 1.
Now we can start the first agenda. Let's sing our national anthem, Indonesia Raya, and UPN Veteran Jakarta anthem. We would like to start the session by inviting everyone to stand up.
gathering where minds converge to discuss and deliberate on the forefront of maritime. This year, we gather under the banner of the maritime industry, sustainable future, ship safety, and energy efficiency. As we navigate the waters of technological innovation and global challenge, it is become increasingly imperative for us to address this key aspect that not only define the efficiency of our operation, but also time sector plays a pivotal role in the global economy, facilitating trade, connecting nations, and fueling progress. However, with this vital role comes the responsibility to continuously enhance the safety standards and energy efficiency of our ship and offshore structure. Ship safety is a non-negotiable aspect of while captivating can be unforgiving, demanding the highest standard of safety protocols and technologies. As leader in this field, it is our duty to pioneer advancement to minimize risks, protect our crew, and safeguard the marine environment. Significant is our commitment to energy efficiency with growing concern about environmental sustainability and the impact of shipping on our planet. It's imperative that we explore and implement innovative solutions to reduce our carbon footprints. This conference provides a platform to share insight, exchange ideas, and collaboratively chart a course towards a more sustainable energy efficiency maritime future. Throughout the course of this conference, I encourage you all to actively participate in discussion, engage with our esteemed speakers, and leverage this unique opportunity to forge partnership that will drive positive change in our industry. As we embark on the proceeding of ICSOT 2023, let us not forget the ultimate goal to contribute to a maritime landscape that is safer, advance. Together, we can shape the future of technology, setting new standards that will resonate across the seas and oceans. Thank you for your attention, and I wish everyone.
Okay, thank you very much to Mr. Fahri for the greeting.
The next agenda is welcome speech from Rector by Dr. Antarvenus, Master of Commerce. To Dr. Antarvenus, Master of Commerce, the floor is yours.
Distinguished guests, dear colleagues, ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh, and peace be upon you all. It is an honor and privilege to stand before you as the Rector of Universitas Pembangunan Nasional Veteran Jakarta, or UPNVJ, and extend a warm welcome to the 8th Indonesia International Conference on Ship and Offshore Technology, or ICSOT, to be hosted by our esteemed university on November 17 and November 18, 2023. As we gather to embark on this significant maritime journey, it is crucial to recognize the rich history and collaborative spirit that define ICSOT. Originating in 2010, at Institut Teknologi Sepuluh Nopember, or ITS Surabaya, this biennial conference has grown to symbolize the unity and shared commitment of Indonesian University and the Royal Institution of Naval Architects, or RINA. The primary objective of ICSOT is not merely to convene experts This year's focus on ship, safety, and the energy efficiency of ocean-based resources underscores the urgency of addressing challenges in our maritime community. Our objective goes beyond the conference itself. We aim to introduce and showcase the expertise of the Naval Architects and Marine Engineering faculty of the UPNVJ, Engineering Department in particular. By collaborating with the Royal Institution of Naval Architects, or RINA, and inviting internationally renowned experts as speakers, we aspire to elevate the discourse and knowledge in our field. I express my gratitude to the organizing committee, the Royal Institution of Naval Architects, or RINA, and all participants for their dedication to making ICSOT 2023 a reality. May this conference be a source of inspirations, knowledge, and collaboration, propelling us toward innovative solutions for the challenges in maritime technology. I look forward to the success and impact of the 8th ICSOT hosted by Universitas Pembangunan Nasional, Veteran Jakarta. And let me express my gratitude as well toward you all who sincerely contributed to this event to make it a success. This wouldn't have been possible without the support of each and everyone present here. I wish you a productive discussions over the course of the conference to make a great impact in the maritime field. To our distinguished guests and participants, thank you and welcome to the conference. Wassalamualaikum warahmatullahi wabarakatuh, and salam bela negara.
Thank you very much to Dr. Antar Venus, Master of Commerce, for the greeting. Distinguished guests, the next event is coffee break. We invite you to enjoy that are available. Coffee break is scheduled for 15 minutes. Enjoy and take your time.
Cek, cek.
Cek. Tes, tes. 1, 2, 3. Tes. Good morning, Mr. Chris Boyd. Do you hear me?
Good morning. Can you hear me okay?
Can you hear me?
Loud and clear.
Okay.
Very good.
So we will start around 9 AM in Indonesian time. Maybe it's around 3 AM in your time, if I correct.
It's a late one, but it's not a problem.
So we will start soon. So please wait a minute.
Good, but I'm just going to test my share screen at the moment to make sure it's working.
Okay, thank you very much.
Just bear with me.
Oh, kayaknya punya Pak. Okay, to the next agenda, we will give to the moderator, Dr. Insinyur Fajri Asfi Rehan, STMT.
Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Salam Om Swastiastu, Namo Buddhaya, salam kebajikan. Introduce me, my name Dr. Fajri. I'm here as moderator for keynote section. For the first keynote, Mr. Chris Boyd, available? Oh, he's available. Okay. I'm excited to introduce our distinguished guest, Mr. Chris Boyd. He is a Chief Executive Officer of the Royal Institute of Naval Architects, RINA. Please join me in welcoming Mr. Chris Boyd.
Thank you very much. And just share screen. If I get my presentation up, hopefully I've got the right one. Just let me know when you can see this screen. It should be up there. Is that correct?
Should be flipped, Mr.
Okay, thank you. If you can see the screen, thank you very much. And my name is Chris Boyd, and I'm Chief Executive Officer of the Royal Institute.
Sorry, Mr. Chris, your presentation should be switched. This is your display. Your display, not our display.
Okay, just bear with me. I'll do some magic. So just bear with me. It's a while since I used Teams, I'm afraid. So, so let me just a little bit of technology. Let me PowerPoint slide. There we go. Hopefully that will do it now. So just bear with me. Oh, this should share. Can you see that? Is it the same?
I think display setting, Mr. Chris, on the top display setting, Mr. Chris. On
Yeah.
top left display setting.
Got it. Yeah.
Yes, right.
Swap presenter view and slide.
Click swap, Mr.
Ah.
Okay, it's very good.
Brilliant. I was doing dual screen, so thank you very much. So
Let
we
me
now
begin
navigate
again.
digital technology. So thank you very much. Well, my name's Chris Boyd, and I'm the Chief Executive of the Royal Institution of Naval Architects. It's an absolute honour and a privilege to be able to present at the International Conference on Ship and Offshore Technology 2023 with the conference theme Ship Safety and Energy Efficiency. I really thank the University Pembangunan National Virtana Jakarta for facilitating this conference, and for Chairman Dr. Fakhri Akbar Ayub and Professor Utama, who's the Vice President of the Royal Institution of Naval Architects, for this kind information. And welcome to my talk on navigating the future of ship safety and energy efficiency. Today, we will explore the current state of ship safety, discuss future trends, and highlight how the Royal Institution of Naval Architects can assist in shaping a safer maritime industry. I will also cover areas of energy efficiency and how safety and the environment can be discussed in tandem. The Royal Institution of Naval Architects was established in 1860 to advance the art and science of ship design, construction, operations, and maintenance. The Royal Institution of Naval Architects is the global body for naval architecture and maritime engineering. We set the standards and ensure professionals maintain exceptional levels of competence, integrity, and technical excellence. Our aim is to drive development and innovation to improve the welfare of societies and safeguard our world for generations to come. Now, don't worry, I'm not going to read every word on this slide, but I think it's important that we start somewhere. And where are we now with safety? So below are a few examples of numerous safety standards and regulations that govern the maritime industry. We're all very familiar with Class Society rules, SOLAS, ISM Code, ISPS, MARPOL, STCW, and COSWIP. But I think it's important that many of our members work in these organizations or sit in peak bodies to influence policy. So RINA is in a unique position to really drive ship safety and the impact of design, construction, operations, and maintenance. What would a presentation be without some statistics? And if you go online, you can find a lot of statistical data about ship incidents, accidents. And I just picked some sample here from Right Data. What it demonstrates is there's factors contributing to safety and incidents. And as we know, human error, weather conditions, equipment failure, etc. But a significant amount of collisions and grounding result in property damage, vessel damage, environmental pollution, and potential loss of life. Fire and explosion incidents accounted for around 10% of all reported ship incidents, which pose a significant threat to crew safety, vessel integrity, and cargo. Oil spills can have a devastating consequence on marine ecosystems. But moreover, human error is leading cause of ship safety incidents, accounting for approximately 75% of accidents, which highlights the importance of continuity of training, crew competency, and effective safety management systems. This does have a financial impact, and ship safety incidents result in substantial financial losses, reputational loss, insurance costs go up and premiums increase, and regulatory scrutiny. So as we look at the current state of ship safety and ultimately the compliance with safety standards and effective risk mitigation measures in the maritime industry, not only do we know that it protects lives, the environment and assets, but also contributes to a positive industry image, increased stakeholder engagement and confidence, and sustainable business operations. So the recent trend in sustainability and the focus on environmental, social, and governance, that's ESG performance, are now impacting the decisions of all maritime stakeholders, along with the emerging contractual and regulatory requirements. The industry is communicating and engaging with an effective strategy towards sustainable shipping. We have to address where we are going. And whilst many of us are getting to terms or understanding the role of artificial intelligence and machine learning, we really are embracing the development of intelligent ship safety systems, the remote monitoring of vessels condition, that's engine performance, fuel consumption, looking at structural integrity, the optimization of ship routes to enhance overall safety of the voyage. But the structural design improvements, fire suppression systems, emergency response procedures are all areas in which we can pick up. There's many more. But one paper I'd sort of delved back into was the Lloyd's Register Foundation. It was a foresight paper issued in 2015, quite old now, but it gave some good insights really into assisting me today with my keynote presentation and identify some of the key safety challenges that exist in structural integrity. We are naval architects. We can talk about voyage optimization. But I think as we look at some of the structural integrity, the materials and degradation and understanding new materials and new methods of manufacturing and how to join them pose real challenges to deployment unless the long-term performance can be understood and taken into account during the design and the operation. We then look at measurement and sensing, the collection and analysis of data ranging from individual systems through to global arrays of systems which create unprecedented opportunities for predicting future condition and optimizing reliability. Simulation and modeling, with better fundamental understanding of the processes that occur, combined with advances in the sort of computing power, it's now possible to better simulate and model how assets will be performing in the operating environments. And as we look at systems complexity and risk, and it's increasing, which can lead to poor understanding of the consequences of parts failing. So reducing complexity and the number of points of potential failure can result in safer and more reliable systems. And there's the importance there of knowledge transfer amongst everyone in the industry. So the emerging trends in ship safety, really, we do have the landscape of ship safety, which is continually evolving as new technologies, regulations, and industry practices emerge. We know that several key trends are shaping the industry's future and driving advancements in ship safety. So automation and remote monitoring, and these technologies are increasing and being incorporated into ship systems to improve safety and operational efficiency. Digitalization and connectivity. The marine industry is really undergoing digital transformation, and the adoption of digital technologies and connectivity is vital. Cybersecurity, as ships become more connected and reliant on digital systems, cybersecurity is a growing concern. The industry is recognizing that the need to safeguard ship systems against cyber threats that could compromise safety. We look at improved collision avoidance, environmental sustainability to achieve decarbonization and net zero. And then the human factors and training that's required. I think the point here I'm making is the importance of the increasing integration of digital technologies, such as the advancement of data analytics, artificial intelligence, and autonomous systems, is enhancing ship safety. That means that the naval architect and the engineer must adapt new skill sets and ways of thinking, or are we already the ultimate systems integrators? A good example is this slide. I'm a digital migrant, and I started off analog within my naval architecture career. But as we move forward and understand autonomous vessels, digital twins, the Internet of Things, all the way down there to sort of data-centric engineering, machine learning and simulation, we all have to adapt. And I think that's what we do as naval architects. We're systems integrators, and we adapt very well. This is not the first time that we've had to look at new practices and new areas of safety cases that come from new materials, new alternate fuels, etc. And I think we all welcome the challenge. The institution not only looks after the latest research and development, technical papers, continued professional development of our members, but we're also actively involved in partner projects. I picked some samples here today of some projects we're working with the IMO. So the first one, which I look at, is the Maritime Cyber Risk Management, that was really the MS3 42898 that came out a couple of years ago. And cyber incidents, as we highlighted on vessels, can have a direct and detrimental impact on life, property, and the environment. We know that IACS has steadily increased its focus on cyber reliance of ships and onboard systems and equipment. Within the UK, the National Cyber Security Centre consortium with the outfit ASME approached the institution to look at the cyber baseline. What does this mean? And it was a maritime cyber baseline that RINA endorsed, which looked at a health check of the vessels, which assessed the minimum security control for safeguarding best practice security for not just systems architecture with IT and OT systems, but also the competencies of people on board that are managing these systems as well. And that's then aligns with the Maritime Cyber Risk Management Standard that IMO issued. So you can see some active involvement that we've got there on that certain project. We then go to the glow noise, which is the concern we have of underwater noise from commercial shipping. This was first expressed in MEPC 7514 a while ago. But the glow noise is a global partnership for mitigation of underwater noise from shipping projects, and it's currently being designed by the IMO, the UNDO, and the Global Environment Facility, with a start date of Q4 2023. And again, the institution's actively involved with this project. The next one, which I pulled out, was IMO Cares. This is coordinated action for the reduction of emissions from shipping. It's a project which has been funded by the Kingdom of Saudi Arabia and is focused on the needs of developing countries to meet the IMO greenhouse gas strategy targets, and thus help drive the achievement of global greenhouse gas reduction. And the last project I just picked up for example here is the Geofouling Partnership Project, And that's a global initiative bringing together key partners to respond to global environmental problems, namely invasive aquatic species introduced via biofouling. So you can see that the institution is actively involved in the way we look and address and changing regulatory framework from the compliance with environmental regulations, such as emissions control and ballast water management, but ensuring that environmental sustainability does not compromise safety, because we have to look at the planning, the investments and the ongoing monitoring. And two examples we picked up here is new technologies and fuels, underwater noise pollution, but then it highlights the need for the skilled personnel and the skills that we require in the institution to represent us in these forums. Those are some slides that everyone in this room is extremely familiar with, and that's the IMO slide on looking at a net zero focus, and then the 2008 baseline and the 2030 and 2050 targets that we've all agreed to. But I think it's important that we recognize that reducing the environmental impact and improving operational efficiency in shipping is crucial for sustainable and responsible maritime practices. I've just highlighted for this forum just some areas in which we're all working on, but it's important to recognize that the energy efficiency measures, that's implementing energy efficient technologies, can significantly reduce fuel consumption and greenhouse gas emissions. And for example, installing advanced propulsion systems such as energy saving propellers and hull designs that we're currently using machine learning, data driven engineering, and also AI to enhance fuel efficiency. We look at alternate fuels and the work in which we're doing to transition from traditional fossil fuels to cleaner alternatives, whether it's we're looking at ammonia, methanol, hydrogen, nuclear. We're going to get there, but what's really interesting for me is we delve back into the institution, and there's one paper in 1911 that was looking at, as we come from coal to steam and then potentially to this thing called marine diesel, how we're going to migrate across, where we're going to bunker. All these problems occurred years ago, but I think the difference is now we've got variable problems and solutions and hybrid solutions being proposed. And it's a very interesting time to be part of our industry and be a naval architect in particular. And as we move down a bit more, I think very important that we really identify that to get there, we've got to do collaboration and really work together on regulation. And that's encouraging collaboration amongst the key industry stakeholders, governments and regulatory bodies, that we drive the development and adoption of sustainable shipping practices. Within international agreements, we've got here the IMO regulations and emissions. It's crucial that we're actively involved. The institution is involved in setting standards and promoting environmental responsibility. It's worth noting that these opportunities should be considered as a part of an integrated and holistic approach to improve environmental performance and operational efficiency in shipping. I'm just looking at my time. I'm just very conscious. It was 20 minutes. This is another interesting partner project in which we work with the Mercer McKinney Moller Centre for Zero Carbon Shipping. Our position is knowledge partners. We are actively involved in the overview and strategy, technological advancement, strategic guidance with the research development framework, and that is to support the centre's vision to decarbonise the maritime industry, in a project we're actively involved with. So the Royal Institution today and tomorrow, I think we really have identified that there is a requirement to what is the 21st century naval architect or engineer. We are systems integrators. We are already working with digital autonomy, data-centric and software engineering. We're project managers. Moreover, with the complexity of vessels now, we're being employed with technical superintendents. We do realize we got different ways of learning, consuming information, and we cover all sectors of our industry. So, as we go forward, the institution does have a vision, and that's to be recognized worldwide as the maritime professional engineering institution of choice. And with the strategy, it's been built on 4 key themes, and that's becoming the international center of excellence for naval architecture and maritime engineering. and the maritime community, and identifying and developing the skill sets for the 20th century naval architect and engineer. We have to inspire the next generation, and that means increasing our membership globally. To achieve this, RINA moving forward has really looked at how we manage our own transformation in particular. We've leveled up the playing field because to be able to deliver what we're doing with partner projects, supporting our membership and supporting technical research and transactions, we had to level up the playing field with an investment in our digital technology, our people, our skill sets. We've set our vision, which is a clear and compelling vision as previously presented. And we've also changed the way in which we are collaborating with organizations so that we're working with a 2024 plus mindset. Supporting this is our committees, and we're an NGO status at the IMO, and we support the IMO with the program. But moreover, we also have a safety, environment and innovation committee that currently are working on other activities with the net zero and the environment. But within the safety, we've got a workshop on safety techniques, safety on container ships, fishing vessel, passenger ships. And with the innovation, it's very important that we address thought leadership. We've already touched on AI, autonomy, cyber, composites, but visioneering. Where do we see the future? What are the requirements that we need to address within the institution, within the industry? I think it's important that we recognize this, and it's a key area that the institution is extremely strong, represented globally, and governments, peak bodies, etc. So before I sign off, I've really got to give some of the benefits, and just, I'm not going to read through the buzz points here, but part of what we do is that international recognition, that networking, that collaboration, but it's the advancement and development of naval architecture, ship design, the advancement of people, giving them that career path, the opportunity for development. We do that through various things of publications, papers, international journals, training, but also networking that's supported by an expert team in the Secretariat. So as I sign off here, we've got the QR code. This presentation will be distributed. People can use their phones, sign up automatically to the institution there. We welcome everyone there, and here's our contact details. But I thank you. It's been a bit of a whistle-stop tour, but I think on conclusion, and I think I've jumped one slide too many as I go back, because I did have a conclusion page, but it's gone. Never mind. I think we've looked at how the institution, or how we address safety in particular, where we are, where we're going, how the institution supports the industry, but also looking at the energy efficiency of ships and how the institution supports local and global peak body activity. I thank you so much for listening to my presentation. It was a whistle-top tour. I'm very keen to keep to the 20 minutes. I think I've got 10 seconds left. But now over to a QA, and thank you very much.
Thank you, Prof. Mr. Thank you for the excellent presentation, Mr. Boyd. Is there any question from participant? I think student first, Prof. Let Farhan, you can. The question only 3 questions.
Yes.
Farhan.
Okay. Yes. Hello, sir. I'm Farhan. I'm a 5th semester student. My question is, it is undeniable fact that security is important. So we need to collect as much data as possible. But if we open source the data, it can be misused, both from security perspective and a financial perspective. My question is, how do we balance the sharing of data to be analyzed with AI, machine learning, big data, and etc., with the security and confidentiality of the data? Thank you.
I think that's a very good question. And I also think there's a very simple and complicated answer, because we'd all like to have a safe space for sharing data. And I think that's the challenge. Having secure, safe spaces. If we look at defense sector in particular, the defense sector wants contractors and they want industry to come and give them answers, but we need access to their information. They've done a lot of sensors, a lot of monitoring over the years, but we need to identify safe spaces. Obviously, we don't want the threat actors coming in and creating noise, terrorism, anarchy, whatever it is. So again, it's trying to identify where we can get a safe space for us to work together. And I think that's the biggest challenge. I haven't got the answer today, but I know that's quite a big challenge in a lot of countries we work in. A lot of energy, a lot of appetite to work together, but it's actually getting an area to do it that's safe. I think that's the biggest challenge. Certainly when it comes to vessel maintenance and vessel security, when it comes to cyber impacts, then yes, the company or the stakeholder has a responsibility there. And I think we've looked at the cyber baseline as a starting point. It's a health check that you would do for a standard, like a suitability survey of a vessel, looking at the minimum standards of safety. Well, we're just looking at it from a point of cyber security in particular. So a very good question. I think there's people in the room that probably have better answers than me, but it's an area which is advancing very, very quickly.
Thank you, Mr. Boyd. The next question, Prof. Martin, Prof. Relinson. I'm sorry.
Thank you very much. I didn't want to steal if another student was wanting a question.
Yes.
Chris, nice to see you. Thanks very much for a very interesting presentation. And as you keep saying, we are the ultimate systems integrators, and we've gone through a number of changes, as you pointed out, going from sail to steam to diesel. So we have gone through a few things. We're going through a lot of changes now as well. In fact, it's a very exciting time to be in the maritime industry, or in fact, a very exciting time to be an engineer in general, because of all the changes that are being made. And I think in your presentation, you made that point quite clear. My question really is, you touched on alternative fuels, and I think it's really exciting where we're going to go in the future with alternative fuels. We have so many different choices. From where you sit, you maybe got a better helicopter view of what different people around the world are doing. Where do you think we're going with alternative fuels? Which of the alternative fuels are likely to become the most popular?
I think, Martin, thank you so much for the question. I think you sort of hit the nail on the head when we look back at some of the things that happened 150 years ago, 100 years ago, when they said, oh, it's impossible. Why would we go to, we got coal. Why would we go to marine diesel? How are we going to bunker? Now we throw in all the complexities of whether we move towards ammonia that's gathering momentum. If I look back 2 years ago, nobody was talking about nuclear. Suddenly nuclear is part of a soft word. We're going to look at this as a potential for the future. I certainly think if we go to this part of the world, in Europe, ammonia is gathering momentum as such. I think there's going to be a hybrid solution depending on what's required for the vessels. We look at some of the stuff that's going on in the northern hemisphere up here, battery power for some sort of direct routing ferries. And I really think it's going to be something that's going to be a hybrid solution, depending on the type of vessel that's required, its performance. If we take defense, for example, they've got a nice power efficiency with what they've got at the moment. So again, what's going to be a good compensation for them in the short term? I haven't necessarily got the answer to that question, Martin, because I think it's something that's very complex. It's at government level. They're looking at infrastructure as well. It's something which I'm keeping very close tabs on within our own IMO committee to see what the latest flavor is. It was methanol towards ammonia, green hydrogen that comes off the offshore wind farm. So again, without digressing too much, I'll probably reverse the question to yourself, because you'll probably have a very different answer to me.
Okay, thank you, Mr. Boyd. Then, Prof. Hikap. Me. Thank you, Prof. Hikap.
Thank you very much, Chief Executive, for your excellent presentation. During your slides, so we can see that one of the goals is to increase the membership and including involve the young generation through campuses. And for your information, in Indonesia, there are more than 10 universities actually with a good focus on naval architecture, marine technology, and so on. And I believe through the concept of a student ambassador, whatever RINA developed at the moment, perhaps could you tell us a bit more, say, would it be possible if there's a RINA competition among marine technology students in Indonesia, collaborate between RINA and the Ministry of Education, Culture, Research and Technology Indonesia. So, and then student membership become more attractive and more young generation would love to join RINA for their future career. Okay, thank you, Chief Executive.
Thank you very much, Professor Utama, and a very good question. And absolutely, we would support this. We want to encourage membership growth, but certainly with student competitions. We currently carry out student competitions in other countries. We've just done a IMO mock competition in India with Lloyd's Register supporting us, and that was extremely successful. And we also organize other student competitions in other countries. So it's something which we've got a lot of experience of. We would certainly welcome this as well. We believe it's a good way to get not just students working together and give them that international network, but it's a good way of collaborating for us and looking at some of the areas of focus that you get in parts of the world that not necessarily are being addressed in other parts of the world. And it could be something you're looking at on fishing safety, fishing stability. It could be a real problem there. So again, it's something that we would support and actually can get this moving quite quickly. And as you know, we've got new facilities and a new team in place to support you as well with this student national competition, and also working with the government, because I know that the ministry should be extremely keen to support the students and the university and develop this. So I would welcome that. We can talk offline. It's certainly something that I would support, and obviously we can look at some of the framework activity that we've already got in place.
Okay.
One more. Next time in the 2024, during your trip, say to Singapore or Australia, please come directly to Indonesia, either to Jakarta or to Surabaya, and we can talk more with colleagues. Thank you.
Thank you, Professor Usman. Absolutely. I'll come directly. It was a shame I couldn't make it this time, but unfortunately something happened at home. But thank you so much for your kind invitation. I absolutely enjoy spending time here presenting, but also during your trips to London as well, where we talked a lot on how we can support you further, not just with your position as Vice President, but with the university and in the region. We're very, very keen to support the region and grow membership and then promote it. So thank you very much.
Okay, I think is enough, Mr. Boyd. Please give applause to Mr. Chris Boyd.
Thank you.
Thank you, thank you. Okay, go to the keynote speaker. I am excited to introduce our esteemed guest, Professor Martin Robert Reynoldson. He is a leading expert in hydrodynamic and currently serving as adjunct professor at Australian Maritime College. Please join me in welcoming Professor Martin Robert Reynoldson.
Thank you. Did you have a remote in the end? Ah. I'll just wait a moment until my slides appear. Ah, very good. Fantastic. Thank you very much. And thank you very much to the university for the invitation to come here. I only arrived a couple of days ago, but I enjoyed myself yesterday and I'm looking forward to the conference today. And I apologize to say that it's only my second time in Indonesia. How do I do? How do I do? Can I change slides? Ah, very good, very good. I just thought I'd put this up just very briefly. Those that were here yesterday for my presentation will have seen the same thing. This is where I'm from here in Tasmania, and of course this is where I've come to. And as I said a moment ago, I'm embarrassed to say I don't come here very often enough. You are our neighbours. We need to have a lot more collaboration and a lot more involvement between the two countries. Is it me doing it or you doing it? Yeah, I'm trying to do it. Anyway, this is just an introduction to Tasmania. We're 240 kilometers to the south of mainland Australia. It's the 26th largest island in the world. An area of approximately 65,000 kilometers with a population of only just over 500,000. So it is very sparsely populated compared to Indonesia. 42% of our land area is protected by national parks, and we have lots of native animals, including, as you may have heard of, the Tasmanian devil. Our major industries, agriculture, timber, and I point out tourism for those of you that want to come and visit us. Tourism is an important industry to us. So I don't think it's me doing it, is it? Or which button should I be pressing? Launceston is the major city in the north, a population of about 100,000, and that's home to the Australian Maritime College. This is just an overview of Launceston. Some of the this is within Launceston. This is a typical walk for me in the morning. So we're quite a different environment to what you have here. Perhaps I could have the next slide. Can you get the remote to work? Oh, okay. Oh, very good. Can I? Sorry? Ah, really? Okay. Sorry about that. So with a little bit of advert for Tasmania out of the way, I just want to start my presentation. So in terms of the contents, we'll be looking at hydrodynamic loading, the global motions. Smooth particle hydrodynamics is a method of predicting the motions and predicting the loads on a ship that I'll be talking about, and the structural response. Yeah, maybe the next. Which button do I press? This one. Oh. Yeah, no, very good. I'll come to over there. Yeah. A little bit of a range problem, I think. So we'll also then go on to talk about structural issues on older ships, and I'm particularly wanting to focus in my presentation about the strength of older ships, the influence of fatigue cracking, the influence of corrosion, and then we'll finish off with some concluding comments. Oh, we've jumped a couple. Anyway, no matter. So ships have to operate in very severe sea states. The structure must withstand hydrodynamic loading. These are just some pictures of ships in severe sea states. Perhaps the next slide. But the point I want to make is not only when the ship is new. This is a nice picture I took earlier this year of a ship in Portsmouth Harbour, brand new, in beautiful condition, but also as the ship deteriorates. You see, this has got a little bit of deterioration, this has got a lot more deterioration, and these are military ships, so they're relatively well looked after. But even so, as a ship gets older, it deteriorates, and we need to make sure that it's structurally safe then. I think I'll give up on that. Perhaps the next slide. So we want to avoid this sort of thing. This is a ship which broke its bow, and this is a bulk carrier which actually came apart. So these are the sorts of things we're trying to do. We're trying to understand the hydrodynamic loading onto the structure, the structural loading internally, and then looking at whether that might cause a failure. Perhaps the next slide, please. Next slide. That's it. The ongoing cost of maintenance is very expensive. It's easy to just say, well, we'll do lots of maintenance, but the ongoing cost of maintenance is expensive. For example, a naval ship, 30% in procurement, 30% of the cost of buying it, the remaining 70% is in maintaining it. This just gives a picture of that. This is buying, and the rest is maintaining. So we don't want to spend too much money on maintaining, but we need to spend enough. Next slide, please. In addition, as ships get older, the cost of maintenance becomes higher. This is a plot here. This is time along the bottom here. These red dots are the cost of maintenance for a particular destroyer. And as you can see with time, that cost is increasing substantially. The lower picture, this is the age of a submarine. And as you can see, the cost of this is the cost to maintain. The cost of maintaining it is increasing as the submarine gets older. So for both surface ships and for submarines, the cost of maintaining is getting older. And the next slide, please. So we need to look at the hydrodynamic loading on the ship. Yep, next, yeah. And from one point of view, the hydrodynamic loading generates global motions. And the next slide, please. Which, of course, gives accelerations, motion-induced interruptions, comfort, and so on. All the things that we understand about when we're wanting to look at the hydrodynamic loading on the ship. Next slide, please. This is just a photograph of model testing. Of course, one way we can predict the loads on the ship, the motions on the ship, is from model testing. Thank you. Next slide. This is the results from model testing. Along the bottom here, we have the non-dimensional frequency, the wave frequency, and up the side here, we have the non-dimensional acceleration. The crosses are our predictions using basic strip theory, and the crosses are the experiments, and the line is the predictions using basic strip theory. Next slide, please. And this one is at a fluid number of 0.58. If we increase to a fluid number of 1.16, you can see that the theory, which is the line, doesn't agree anything like as well with the experimental results. So as we're going to more extreme situations, the theory, the simple strip theory, doesn't work as well. Yes, next slide, please. What we do, of course, with that is we take our, this is our same thing, non-dimensional frequency along the bottom here, acceleration up the side. This is our results. We take this and work out what the motions would be in irregular waves. So along the bottom here, we have the significant wave height, and here we have the accelerations. And you can see for these low cases, the agreement is quite good at this low fluid number. And the next slide, please. However, as we go to the higher fluid number, where the agreement here wasn't as good, the agreement, again, significant wave height along the bottom here, the agreement is not very good at all. And the next slide, please. We can then generate a graph that looks something like this, where this is significant wave height along the bottom, and this is vessel speed up the side. And we can have an acceptable range, acceptable area, where the predictions are working quite well. We can predict the motions of the ship, where we're going at a relatively small wave height at a relatively low speed. If we increase the wave height, increase the speed, we get into an area where we cannot predict anymore. Next slide, please. And the reason for that is things like this. This is a model experiment showing a ship in the water, slamming, deck wetness, all sorts of nonlinear response that we're getting as we move into larger waves. And the next slide, please. Yep. This is a result from full scale. This is time along the bottom here. And this is the stress on the ship. And you can see the slamming occurring as we're moving along. Very much a nonlinear response that we're getting from the ship in the waves when we're getting some severe slamming, as we see in this is model experiment, this is full scale. Yes, next slide, please. So how can we predict the hydrodynamic loading on a ship? We can use strip theory, which has been around for 20 or 30 or more years, and that gives a reasonable prediction with the small loads, small forces situation. Oh, or we can use or we can use panel methods, which we might use for larger wave situations. And now the next slide, please. Or we can use a method called smooth particle hydrodynamics. And I'm going to talk a little bit about smooth particle hydrodynamics because it's quite different from the normal computational fluid dynamics that most people will be familiar with. So the next slide, please. With smooth particle hydrodynamics, the fluid is represented by a large number of individual particles. So we have our particle here, for example. Next slide, please. And the properties of the particle here are influenced by all the other particles. And the other particles will influence that particle. And there'll be a smoothing effect. So the further away you move, the less influence it will have. And the next slide, please. And each particle then influences the neighbor to a different degree. And next slide, please. Yep. And so what the point about this is we need to look at the ocean, to look at the water, we need a very large number of particles. And that means we need a very large computing resources. So this method is nothing like as simple as basic strip theory or anything like that when it comes to the computing requirement. But it has the ability to look at very non-linear shapes, non-linear motions. Next slide, please. This just is an example of how it looks. So this is our ship in a tank. These are all the particles. And basically the particles are kept in the tank using a tank of water by a contact interface that we have here. They're also kept out of the ship by a contact interface around the ship. Next slide, please. And this contact interface, oh no, you've gone one too many. This contact interface around here, the particles are all providing a force on the ship. And that means that we can obtain the forces on the hull plating very easily, directly from using this method. Yes, next slide, please. And this is the way we set it up. We set it up in much the same way as you would set up an experiment in a towing tank. So this is the equivalent of the towing tank. We're measuring the waves here. The waves are propagating down this way. So the waves are coming from here, moving down here. This is where the ship would be. And we're measuring the waves as these particles all cause the wave to move along. Yes, next slide, please. This is just another example showing how the ship is moving in the wave. And the next slide, please. These are just examples. You can see the splash of the water coming off the flare of the bow, as you would see in a towing tank, or you would see in real life. And the next slide, please. This just shows to illustrate that it doesn't have to be a strip, doesn't have to be a simple shape. It can be a complex shape, traveling in waves at an oblique angle. The smooth particle hydrodynamics method doesn't matter. It doesn't care what the shape is. And the next slide, please. This is going to be a video, so if you could press the button, it should start the video. Yep. So now you can see the animation of the ship moving through the wave. And you can see, as you could be on a towing tank watching this in nice regular waves, or even at full scale, this sort of thing. So this is what the smooth particle hydrodynamics can do without any sort of approximations that you might need that you would use with strip theory. Okay, so we move to the next slide. And the results are very similar to what we would get. This is non-dimensional wavelength along the bottom here, and this is pitch. And the dotted line is the simulation, and the crosses are our experiment. And same thing here, this is heave, non-dimensional length along the bottom here. The crosses are the experiment, and the line is the simulation. So we're predicting the global motions of the ship. Next slide, please. So now we've talked about how we'll predict the global motions of the ship. And next slide, please. What I want to do now is move on and talk about the structural response, because it's the response of the structure to the global motions which is going to cause the ship to fail. We've got the next slide. So what we're taking is the structural response and going on into structural loads. Okay, next slide, please. Now, what I'd like you to do in a minute is just run through the next 8 slides. You see we've got slide 1 through to 8. But before you do that, I just want to explain. Yeah. So this is a ship in a wave. Here's a wave. You can make out that there are smooth particles, number of particles in that wave. And along here, we've got the length of the ship, and here is the load, the local loading as we have along here. And this is just a picture full scale. So if you could just press slowly through 1 to 8 of these, you'll see the ship moving through, you'll see the loading changing. If you keep coming, you'll see the loading changing as we go through the wave, keep coming, and then you'll see what's happening. And then the next slide then just shows a summary of all these along the length of the ship. So each of these lines is at a different moment of time that we just saw as the ship is going through the wave. And that's the external loading on the actual ship. And that comes quite directly from the smooth particle hydrodynamics approach. Okay, so next slide, please. This then shows the bending moment at midships. This is time axis along the bottom here, and the bending moment here. And the red is 1 meter high wave, the green is 2.5 meter high wave, and the blue is the 4 meter high wave. And you can see the peaks occurring as we're getting slamming occurring in the larger waves. And if we go to the next slide, please. This is just an exaggeration of that, where we have time along the bottom here still, and the moment up the side here. You can see here, we're about to go into a slam situation. We're here, and as we go into the slam, you can see the large bending moment occurring with the blue curve in the higher wave. So it's just an emphasis on the previous one. So I've shown the numerical way of obtaining the loads, the external loads on the ship. How do we do that from an experiment? Because the experiment, we can measure the overall motions, but we want to understand the loads on the experiment. So we do that by taking a model. This is a model in the ANC towing tank, and we have the hydrodynamic model, but we connect that from time to time. So this bit is a section, this is a section, this is a section. These are not actually, the fiberglass is not actually connected there. It's just filled over. And then if you look at this diagram here, this picture here, we've got our various sections, and each of these sections is attached to this strong back or this strong beam with strain gauges. So by doing this, we can measure the forces on each of these different sections in waves. So it's a rather complex experiment, but it gives us the ability to know the forces, the bending moments on the ship, rather than just the global forces. The next slide's done. So this is the reason for this picture is just to show we can do this on a catamaran as well. It doesn't matter what sort of shape you can come up with and do whatever, do it on a catamaran too. Okay, so next slide, please. So the question is, that's a segmented model with a number of segments. Is that the same as a fully flexible ship? In segmented model, we've got rigid sections joined together. Are the two going to give us the same result? So here is an FE model of the ship completely with its normal flexibility. Here is an FE model with the different sections. And each of these sections is joined. So the next slide, please. This is a comparison of the two results. So this is time along the bottom here, and this is the bending moment up the side. And you can see that the two results are pretty well exactly the same. So what that's saying is if we use a segmented model, physical segmented model, we will get the same bending moment as if the whole ship was flexible in real life. And this is quite a large wave, fairly high speed for this ship and a very large wave. So we've deliberately chosen an extreme case to prove that this works. Okay, next slide, please. And then the results then, this is again our wavelength along the bottom here. And this is the bending moment up the side here. Here we have the hogging results. Here we have the sagging results. And I just put there, this is, I'm not sure in how it translates. This is hogging and this is sagging. And you can see then this is our sagging results. These are our hogging results. The stars are the experiments. The crosses are the experiments. And the lines are the predictions. And you can see we're getting reasonably good predictions. Next slide, please. The other interesting thing is what happens as a function of wave height. So as we get higher waves, what happens? So this is a graph, this is wave steepness along the bottom here, and this is bending moment here. This is our hogging, and you can see actually, if anything, it looks like the hogging is getting a non-dimensional hogging is getting slightly less as we go to higher waves, whereas the sagging is getting more as we go to higher waves. I don't think we understand quite why that's the case. There needs to be a lot more research done into that. But the key takeaway from this graph is the fact that we're now looking at the effect of increasing the wave height. Next slide, please. This then just shows, up until now, we've been looking at in a head sea, simple case. This shows there's no reason why this can't be done in an oblique sea. Here's the wave crest here, wave trough, wave crest. The next slide, please. This is then an animation of the vessel traveling in an oblique sea. What we're going to look at in a moment is the longitudinal stress, the changing colors. So if you just watch that as it goes through, we are now seeing the longitudinal stress on that ship as it goes through the waves. And if we go to the next slide, this is, oh no, it's still the next slide. This is the torsional stress. Okay, so we press, you'll see the animation going. As we go through the waves, we've now got the torsional stress. So the point is we're able to look at the stresses internally within the ship using this method. Okay, if we go to the next slide, please. So we've now said we've looked at the structural response, we're looking at the structural loads. If we have the next slide, what we want to do is see how these loads are shared across the elements of the structure of the ship. So this is just a picture of the ship. This shows the elements. This shows how the ship is made up, very much idealized. And if we have the next slide, please. What we want to do is look at the sharing of the loads across the elements, and then we want to look at the metal degradation. What happens to an older ship as the metal it becomes poorer? We will have fatigue, we'll have cracking, and we'll have corrosion. So what effect does that have on the safety of the ship? Okay, so we're looking at the structural design criteria will clearly be for the ultimate load, and we might pick a number of cases, a number of design waves, a number of vessel speeds, a number of vessel loadings, and this is just one case where we're looking at the ultimate strength. Okay, the next slide, please. And what we want to do is understand how the internal structural loads, how the sharing of these loads across the various elements. And the next slide, please. But we're also interested in fatigue. So we're interested in over the period of not just one-off ultimate load, but also what the fatigue is going to give us. And we need to understand the operating sea states, profile, and length of time. So we can go to the next slide, please. And the next one. Yep. So this just shows a frigate in a sea state, in a head sea photograph. This is using SPH, same sort of picture. So we're using this information to feed into our structural model. Okay, if we could have the next slide, please. Oh, no, one back. Yep. So, like I said, for fatigue, we need to understand the operating sea states that the ship is going to operate in. This is an example of a sea state we might be operating in. This is the period, and this is a significant wave height, and this is the probability of each of these occurring for that sea state, for that ship. Okay, the next slide, please. Yep. Can we do that? That's it. We also need to know the speed profile. So this might be the speed profile of a particular ship, where this is speed, and this is percentage of time that it's traveling at that different speed. So we need to know the sea state, the speed profile, and then the next slide, please. And the length of time that we're operating for. Are we operating for 100 days a year? Are we operating for 50 days a year? Are we operating for 300 days a year? How long we're operating for? And that then gives us an assessment of the fatigue. So the next slide, please. And again, we'll then can share the information across the elements. No, it's okay. We can go to next. But what we want to do, that's all very well for an intact ship, something that is as it was built in the first place. What we want to do is consider fatigue and cracking that might occur and corrosion that might occur. These are things that will occur in an older ship. We still want the older ship to be structurally sound. So the next slide, please. This is example of some of the degradation, the structural degradation on Australian warships. There's a couple of examples I'm allowed to show. We've got cracks, and the survey found 3 dominant effects: cracks and fatigue. And the next slide, please. Collision or impact damage, obviously. And the next slide, please. Corrosion. So these are 3 things that we found could be happening to the ships as they get older. And for the naval vessel, we found that corrosion had the most widespread effect. So we go to the next slide. So the question is, which of these will dominate on other ships will depend on the ship usage. If the ship's used a lot, it's quite likely that fatigue is going to be an issue. If the ship's not used a lot, it's quite likely that corrosion is going to be the bigger issue. Corrosion will take over because we're not running the ship so much to get fatigue. So the next slide. So I want to just look at the effect of cracks. And we assume that a 4mm crack is the minimum that you would pick up in a inspection. So the crack will then increase in time, and the rate of time, the increase in time will depend on the rate of vessel usage, the number of days per year. So also it will depend on the sea area the vessel's used in. So we're using this example, Northern Australia here. You see the probability, the most probable waves are, this is wave height. This is wave height along the bottom here. This is the probability. So the most probable is small wave heights. On the Southern Ocean, the most probable goes to much larger wave heights. So obviously it's going to depend on where we're operating, how much that crack is going to, how quickly that crack is going to move. And the location of the crack. Obviously, if the crack is somewhere on the ship where it's not getting much stress, then the crack is not going to expand. So the next slide, please. This is an example where this is time along the bottom here, and this is crack length up the side here, always starting at 4mm. This is time in number of years. And so in the Southern Ocean, this red picture, you can see that the crack extends quite quickly. Whereas in the Northern Australia, where the waves are less, the green lines, you see the crack extends with time much smaller. And these different lines depend on how much it's being used. So the next slide. So we have a time taken for the crack to grow from 4mm to 40mm. In the Southern Ocean, if we use the ship for 104 days a year, it'll take 16 years. If we use the ship 146 days a year, it'll take 11 years. In Northern Australia, if we use the ship for 104 days a year, it takes 33 years. If we use the ship for 146 days a year, it takes 23 years. So we can analyze this sort of thing and say how much we're expecting the crack to be extending over the period of the ship's life, depending on what operations it's doing. Okay, so next slide, please. So the other area was corrosion. And we can measure the corrosion, of course, during the inspections. So next slide, please. So what we're doing is we're varying the corrosion on this part of the hull, just in our simulations, and saying what happens if there is more corrosion. Next slide, please. What happens if there's more corrosion occurring down here? So we're assuming we're taking this area here and reducing the thickness, assuming that it's got more corrosion. That's what we're going to do. Next slide, please. And this is just showing the ship going through the waves with the reference case being 100% of the original thickness. And the next slide, please. And then this is showing the strain, or the stress rather, on that particular plate that I was looking at as a function of time. So this is time along the bottom here, and this is the stress up here. And you can see if we've got the full thickness, we're not getting very much stress. As we reduce the thickness, we're getting a lot more stress. That's what you would expect. That's the sort of thing you would expect. So this is the key slide as far as that's concerned. We have the percentage remaining thickness along the bottom here. So this is 100%. And so this will be our strain, or stress here rather. As we reduce our thickness, we will increase our strain. So that well, the class would say, when we're at this point, we have to do maintenance. But actually, the strain or stress rather is still quite low. It's 0.4 of the maximum. So actually, if we did maintenance at this point, we would be over maintaining the ship. We would be spending a lot of money that we don't need to spend because the stress is not very high. But as the corrosion increases, then obviously the stress is going to increase. And eventually we'll reach a point where we will now reach the fatigue strength threshold. So at this point, we definitely need to be maintaining the ship. We certainly don't want it to extend up to 1, because 1 is where we're going to get elastic deformation of the steel. So this graph allows us to say, don't need to maintain it here. We can save money, but we do need to maintain it before here. So as we are measuring the plate thickness reducing due to corrosion, we can plan our maintenance more sensibly. And the next slide, please. So we're proposing that what should happen is that charts indicating the stress magnification factor, if you like, as a function of the plate thickness, should be able to be used, should be able to be developed. What we've looked at is only one sea state and one condition. Clearly, this has to be done for a lot more cases. What we want to try and do is avoid this sort of thing occurring, so we can understand the relative criticality of the structural defects. Some structural defects may not matter. We can, by doing this process, we can see which structural defects are causing problem and which aren't. Next slide, please. The relative risks of deferring the defect rectification. Some cases we must repair straight away. Other cases we can say, no, we don't. That previous graph showed us where we might not need to do it. Next slide, please. And how that such defects will influence life extension. Life extension is particularly important for military ships where they're built for 20 or 30 years, and then the military needs to extend their life because the government hasn't given them money for the next ship yet, and that's quite common in Australia. So it may result in a considerable cost saving and increased ship availability. If we go to the next slide, whilst ensuring safety. We're not trying to say you don't need to maintain the ship, quite the opposite. We're saying you need to maintain the ship, but you need to understand what the stresses are around the structure of the ship as it's going through the wave, so that you know what we need to maintain and what we can get away without maintaining. Next slide, please. So just to finish off, I've talked about a very brief introduction. We talked about the hydrodynamic loading, and the hydrodynamic loading is something everybody understands, the global loadings and so on, and structural response. But what I wanted to do was spend a bit of time looking at structural issues on older ships, the influences of fatigue cracking, the influence of corrosion on the stress on the structure to ensure the structure is safe. And then finishing off, and maybe the next slide. What we want to do, of course, this is Napoli. I managed to get quite a few different photographs of ships which have suffered cracking, and they rescued this ship and it's sitting in the dry dock. But we want to avoid things like that. Now, if it's possible, if we've got time, can you click on that link? If you're connected to the internet, I
made 20% returns in 4 days from one powerful option trade. Now,
see the picture?
Share screen-nya.
It doesn't matter if you can't get it. That's me.
Peace.
This is motor vessel Arvin, Mayday, my vessel broken, my vessel, Mayday, Arvin.
Тонем, съебуй!
I'll leave you that link and you can look it up yourselves later. If we can go to my very last slide, just to have that up for I've no idea of the whether that was a spoof or whether it was true. I just found it on the internet. Can you go to the very last slide? Yeah, that's fine. Perfect. Thank you very much. I think that's timing is good.
Okay, thank you, Prof. Redson. Please have a seat, Prof. Is there any question from student or from participant? Is there? I think I have a question, Prof. Oh, there is a question from Mr. Fatin.
Thank you, Professor. I want to say welcome to Jakarta. I have two questions. My first question is, this is my learning scope. That's my first question. So the second question is, cracking in the shorten, the cracking is faster than.
Yes. To answer your first question first, yeah, the Australian Maritime College is based in Launceston, and that trains seafarers, deck officers, and marine engineering officers. It trains naval architects and maritime engineers. That's the department I started, and it also trains people in seagoing logistics, maritime logistics. It used to be a national organization in Australia, but it's now been taken over by the University of Tasmania, which is based in Hobart and Launceston. So yes, but the national place for doing naval architecture, if you like, in Australia is in Launceston. That's why I live there. Your other question, it might be better. Is it easy to go back to our presentation? It might be better to answer that with the presentation if I can. It might be easier for me to flip through. Find at the beginning. Towards the end. Keep going. The next one. Keep going. No, that one. To answer your question, oh no, that one. So this is the area, the various areas. This is the size of the waves in the areas, the probability of the large waves in the various areas. So in Northern Australia, which is sort of up here, this is significant wave height along the bottom here, and this is probability up here. So you can see that in Northern Australia, most probable waves are quite small. In Southern Australia, down here, the most probable waves are a lot larger. There's a lot more probability of larger waves. So the simple answer is that in Northern Australia, and I guess in Indonesia as well, you have less high waves. And in Southern Australia, Southern Ocean, you get much larger waves. So as the ship is spending longer in the larger waves, the stresses are going to be a lot bigger, and the crack is going to increase quicker. Does that make sense? So part of the analysis of a ship's fatigue life and the crack extension, you need to know where the ship's operating. So if the ship is always operating in Indonesian waters, for example, you might be able to say, well, I've got a little crack, that's not going to grow. I feel comfortable about it. But if you took that ship and went down to the Southern Ocean, that crack might grow very quickly and you would be less comfortable. It's understanding that sort of thing is what we're trying to do.
Okay, the next question from Prof. Ikap.
Thank you, Martin. It is very interesting. Why? When you use the vessel problem, because of oil of Bengal, when with the oil use, oil can the operating costs. If you stop could cost more also when we have to prepare the vessel.
Yes, what you say is very true. And of course, I oversimplified it deliberately because of the time and so on. But the corrosion and cracking are related. And of course, fouling can be related too, if we're talking about external. If we're talking about internal structure, probably fouling doesn't have that big a deal. But if we're talking about external structure, like the hull plate, if there's cracking occurring there, then corrosion could, fouling could have an influence. Internally, probably less so, but perhaps what you're also alluding to is that the corrosion and the cracking are related. So we have cracking caused by the corrosion, and I've sort of simplified it by neglecting that, which is not correct, of course. I'm not sure if that answered your question.
Okay, more or less okay. One more question. The particle of usually we consider as a unity of bulk system. In a computational fluid dynamics, we have a Eulerian.
Lagrangian. It's not so similar. What you're talking about, which is the traditional way of doing it, is having a mesh. You're setting up a mesh. What with the SPH, or in fact other particle methods, we're not setting up a mesh. We're just putting particles into the water.
Okay then.
So there's no mesh controlling these particles. These particles will go where they want to go, just like the real water would do. So and I've just referred to smooth particle hydrodynamics here, but actually the project I'm working in, we're starting to adopt another particle method, FPM, finite particle method, which is slightly different, but the same concept. The idea is you throw away the mesh completely and just put particles in the water.
Okay.
Now, obviously, there's some topics you can't look at. You can't look at resistance, for example. You can't do things like that. But for seakeeping, it's probably a very good approach, provided you've got the computing power, because these particles take up an enormous, every time step, you've got to see which each particle moves across that whole domain. So it's a different approach altogether.
Okay.
I think it's got the future to look at nonlinear shapes, to look at catamarans, to look at multi-hulls, to look at all sorts of other things in large waves, but you have to have the computing power.
Okay, thank you, Martin.
Okay, I think there is a last question, Prof, from Mr. Boyd.
We've got time. Martin, excellent presentation, and thank you for simplifying it, because I had to keep up, and it was excellent. Towards the end, you were looking at older vessels and certainly operating the simulation against model testing in higher sea states or higher HS. And you said that you got to do more research into, you were seeing increased hogging, but less sagging. Have you got a theory on that, or are you going to take the Fifth Amendment?
No, I'm sorry. I don't know. I don't know why that should be. It's, you know, the actual magnitude is staying the same, but the total magnitude is the same. But as you say, the hogging and sagging are different, and quite why that should be, I don't know. It's clearly some sort of non-linear influence. You wouldn't normally look at that. You wouldn't normally look in that level of detail if you were doing normal motions predictions and so on. It's only because of what we're doing that we found that, and we've only done this on the one vessel. And as I mentioned, it's quite computationally intensive. So it may be that it's only spurious and it doesn't happen on other vessels. I don't know the answer to that. I'm sorry. Wish I knew. But as you know,
No, that's interesting.
as all academics say, more research is required.
Thank you. Thanks, Martin.
I think this is the last section for Professor Martin. Please give applause to Professor Martin. The next agenda, we have the unique opportunity to delve knowledge from Dr. Insinyur Setio Nugroho. His experience promised to enrich our understanding of transportation system. Please join me welcoming Dr. Insinyur Setio Nugroho. Monggo Pak Setio. Pak Setio.
Terima kasih. Selamat pagi. Good morning, ladies and gentlemen. I would like to present. I will try. No. Okay. Okay. But basically, you could put the view. Yeah. Okay. I rely on you. Ini udah bisa. Nggak bisa. Saya present lagi. It is an honor for me to be here. It is great that we have the opportunity to discuss things which concern us. I would like to address topic. Arahkan kemana nih saya? Ini kan ya? Okay. My presentation is titled "Why Safety Needs More Digitalization." This portray a stack of containers on board of the ship collapsed, and next, and this one is also another accident in Bali Strait. 7 years ago, this ferry capsized, and this portrait, it is not a nice one, of course, but it concerns us very much, as the probability that this kind of portrait will appear again in the future seems to be open. Next. As presented by Professor Renilson earlier, a ship might break in two. And this one and also the previous one, a barge being loaded with coal, and this one with a huge ship with containers on board. Next one. Okay, next. I show this picture to illustrate how ferry is being loaded with trucks, and when trucks come in, and a teleman takes note on a cartoon, and this is a common portrait today still. It shows also that the industry, maritime industries, is a very conservative one. Conservative in the sense that they are reluctant to adopt new technologies, including information technology. Next. This is actually our motivation. We do our research not in vacuum. We consider what concerns us today and in the coming years. Next. Climate change is taking place, has been taking place for a while, and the temperature is rising, and we see now in Indonesia, it is hotter than last year. What we are aware of is actually that its impacts are far bigger than we might think of. Let's take a look at the next slide. This is the previous picture in a number of years, but this one is only for this year. It shows that the red dot is the average temperature this year, and the black dots are average temperature in the past 30 years. You see the difference already clear on the chart. Next. I would like to show a few hints that the weather affects us very much, and the bad weather affects transportation, and it happens in many places in Indonesia. And this is actually a portrait of weather forecast May this year, and it shows already that information technology could help us to save the connectivity, the transportation, and without this, we could not imagine how bad the impacts could be. Next. The information on bad weather is there, and sometimes it is also lacking due to communication, and the postponement of ship's departure is actually something which we experience in times of bad weather in many places in Indonesia and also in the world. And it is not difficult to predict when climate change trend remains the same as today. the postponement or even cancellation of ships departure might take place more in the future. And its consequence is that the number of voyages conducted in a year will reduce. The transportation cost will rise, and also it affects to the economy, meaning the prices of goods will increase as well, and the passenger tickets will also increase. Next. The next challenge is actually electric mobility. Electric cars are in trend now. All over the world are very keen to see green things, reduce fossil fuels by adopting electric cars. Also in Indonesia, the number of electric cars are rising exponentially. And we would see the trend will go on probably until 25 years ahead. Next. This is a sad story. 40 cars on board ship from Germany to USA last year. The ship is in fire. And the reason is electric car on board. And a particular property of electric car is that its fire is difficult to make it off. And after 2 weeks being in fire, the ship capsized. And next. The concerns are already there, but IMO has not made any rules on this, how to carry electric cars and its batteries safely. And as the problem are viewed very urgent, a number of institutions take initiative. European Maritime Safety Agency, for example, they have set up guidance, not the rules, but guidance. And the property of cars are identified. They are, in average, 25% heavier than average cars. And also during the loading, that's actually the critical one. Today, also in the past, cars must supply information about the physical dimension, size, and also weights. But now they have to inform as well what is the source of energy. It is battery or fossil fuel. And a particular important thing is also the ship must supply the information about the exact location of electric cars on board, and it must be informed to all crew that electric cars are stored somewhere. In case of fire, they could access the cars easily. Next. I have shown 3 challenges. The first challenge is human errors. This is actually something raising awareness among us. As next. 88% of accidents, this is statistical in Indonesia, 88% are caused or related to human factors. Next. Now, our study conducted by our students, our PhD students, she identified 200 accidents, and out of these types of accidents, capsizing. And she identified critical risk agents for ship's capsize. On the chart, the 6 sources of accidents, she called it the risk agents, are 80% of the frequency of ship's capsize. Out of 6, 5 are related to the loading process. An example, there is no update of stability calculations after the completion of loading, and there is no weight inspection because the information on the weight is inaccurate. No storage plan, no physical stability check on board, and improper lashing. And you could imagine this is around 80% of the frequencies. Next. In line with the growth of population of electric cars, the electric battery industry is also growing. Indonesia is a major producer of nickel as a source of electric cars battery. We produce a lot nickel ore, and we carry a lot also nickel ore. And a particular property which is prone to produce accidents is actually the liquefaction of nickel ore. And a few accidents already taken place. It is why it belongs to human factors. Liquefaction takes place as the moisture level of the cargo is not well measured first, and also discipline to take care of it, that the moisture level must not go beyond a certain level. And in case of liquefaction, bulk cargo like nickel ore might turn into liquid on the surface. So it is easy to imagine that free surface effect might expedite the process of capsizing. Next. This one is a case of ship accident in Toba Lake in North Sumatra. MV Sinar Bangun capsized with a number of casualties. The first point in the chart is actually it is actually the report to the public published by media. In the very first hour, the number of accidents, the number of casualties were around 50. In the next few minutes later, it rose into close to 140. And it goes up and down, and it ended up around 200. It is something shameful actually. We could not have an information how many people are on board. It is not a rocket science actually to provide such information. And the consequences are severe. When we talk technicality, it is its consequence and stability is also obvious, but it is also interrelated to other aspects, including economics. Next. I draw this chart. The x-axis is the number of the identity of the reports as time series, and the y-axis is the timestamp. In the first around 20 reports, it is published within 3 days or so. And so every hour, every minute, there were also reports about the updates of the casualties. When the number of casualties became more stable, then the publicity is getting calmer as well. It is decreasing. Next. It is something which we cannot ignore. The portrait of safety is so this is our concern. Next. Now we take a wider look into the world. The loss of vessels worldwide in the past 30 years has been decreasing. The investigation of the ENVI reveals that the decrease of loss of vessel is due to digitalization. Next. And IT itself is also increasing. This is statistic in Indonesia. The number of users of internet is growing very fast. The speed of internet is also moving up very fast. The size of storage and hard disk is also going up very fast. In short, IT is more and more advanced, faster, but at the same time more affordable. So, why should the maritime industry remain conservative? As IT shows its benefit, more advanced and cheaper at the same time. Next. Now I highlight the view from the maritime industry, from marine insurance industry. Insurance industry plays a very important role as a guard in the system. Digitalization in marine industry drives the practice to conduct physical surveys at site more efficient. Why? The information is could be obtained faster and also with a better accuracy. So quick and comprehensive insights are already available. lower survey and analysis costs, and also finally it results in a better operational efficiencies. And having this, the insurance company is willing to provide lower insurance premium to shipping companies when shipping companies are equipped with better digitalization. Next. And actually, the benefit of digitalization are enjoyed by all parties, including by shipping companies. When the lower premium is provided by insurance companies, maritime industry could benefit as well. So it is actually an incentive for maritime industry to do more digitalization, and for the society will enjoy improved safety and also better compatibility with international trade. What I mean with better compatibility with international trade is the digital divide is taking place not only among people in the society, but also among industries. The shipping industries in a developed world, they are far more digitalized than in developing countries. And international maritime organizations have already established standards to exchange data in a certain data formats. And without digitalization, developing countries cannot catch up with modern international trade. Next. And when things are correct, when the data integrity is high and fast, a ship like a ferry, for example, they could send everything very quickly and with a maximum accuracy to harbor master, to shipping companies in real time, very quickly, and the clearance process could be proceeded. That's actually where the problem is, where the stability calculations are not accurate, where the cargo manifests are not accurate. Why it takes so long to do it manually, and it is prone to mistakes when we do it manually. Next. I would like to illustrate our story, ISTO story. Next. This is our motivation. We should get rid of those things because it lacks accuracy, it lacks speed, and we aim to digitalize into a more, I would like to say, civilized. It's a bit too hard, but a better way. Next. It is a portrait on board catamaran ferry in the Philippines. This catamaran ferry serves Batangas and Catalan back and forth. And this catamaran ferry uses ISTO, a loading software installed on board ship. And next. And this software, excuse me. Previous version, right? Oh, hold on. It's okay, no problem. Next. This is actually the look of our loading software, ISTO. And this loading software originated in 2006. We started the development in 2006 and the very first version in 2007. Now, today, it reaches the version 2.5. And so the look of the loading software in 3D. And next. And this is actually the ship on board this ship, the previous picture. Next. And the software has been certified by classification societies, including Lloyd's Register and also other IACS classification societies today. And software runs next. This is a part of a group of loading softwares in the world. There are 20 countries in the world which produce loading software. And since 3 years ago, Indonesia joins the club, becomes one out of 20 countries producing loading software, where ISTO is. Next. And this is the 2D, two-dimension view of the software. Next. The 3D view. Next. The software provides also templates of vehicles, when in the case of a ferry railroad, and the vehicles related to their categorization is determined by national regulations. In our case, we have when we install on board a Filipino ship, we have to modify to adapt to the national system where the categorization differs from Indonesian system. Next. I repeatedly mentioned about the role of human factors. And this is something which we are very thankful to Lloyd's Register. The idea when we proceeded with the certification process, we have a full set of calculations, stability calculation, intact stability calculations, damage stability, bending moments, shear forces. And we identify also critical elements when a ship could be in risk. And this is actually something which would minimize the risk of unnecessary human errors, the visual alarm. So on this side, this is a list of 8 IMO safety criteria in the area of stability. And when one of the criteria is violated, then the cell turns red, otherwise green. And apart from it, next, we provide also audible alarm. So when one of the criteria is violated, not only stability, but also strength as well. the computer will produce beep sound uninterruptedly. Next. These are the facilities of the software, IMDG codes, the Exchange International EDIFACT format, namely by BAPLI, number checking, and also the software could identify when the containers are located wrongly, flying containers when there is nothing below. Those are the things which are provided by the software. Next. This is something which I would like to highlight. To produce a safe transport, it is not about hardware and software, but it is also about humans who operate the software. We developed a cargo handling simulator. This is actually a derivation of ISTO for this purpose. And it is used by a few seafaring maritime polytechnics in Semarang and also in Ambon, where the simulator could be used both for trainers and trainee. So the trainers could produce scenarios, meaning situations on board ship, and the trainees could solve the problems by moving the containers on the screen to achieve safe situations. The safety criteria are not violated. And also it is provided in a game mode as well. For example, how to achieve safe stowage plan within 100 moves, for example. And it is provided, it is also equipped with grading for examination purposes. Next. This is a portrait of education in maritime polytechnics in Semarang, Central Java. Next. The last one. Stowage planning, loading is not only an area of safety, but it is also connected to other things, including fuel consumption. 3 years ago, no, not 3 years, 4 years ago, we collaborated with the DNV to connect our software with theirs. The DNV has a software, the trim optimizer software called Eco Assistant. It works this way. The hydrodynamic properties of a ship in every trim situation differs. And there is a point when in a certain trim situation, the fuel consumption is minimum. And therefore, the software ecosystem is functioning. And an example, when the trim the optimum trim is around 1 meter, for example, and the thing which which could implement or achieve that situation is by moving the cargoes or ballast water. And that's actually the task of stowage plan. And therefore, the idea came, why could we integrate, but don't we integrate those software in one screen? So this is actually the screen of Eco Assistant accessed from the window of ISTO, because the recommendation of ecosystem is implemented by ICSOT, and the update of ICSOT situation will be sent from ICSOT will be sent to ecosystem to obtain the actual fuel consumption. So back and forth, and it is done. It is implemented. Next. So there are three. First, when we talk about safety, digitalization shows its benefit. It could address maritime safety challenges effectively. So we should promote digitalization in Indonesia as well, and also in other developing countries. And the second one, humans. Humans are very important. They operate the machine, they operate the software, they operate the ship. And also, they later on decide how much digitalization should be contained in the organization. Computer-based training is an essential part of STCW Manila Amendments. So this STCW Manila Amendments mentioned that a cadet must master knowledge how to operate a computer-based system. So computer-based education is compulsory under this STCW Manila Amendments. And the last one, ICSOT is a story starting in 2006, and from basic research to applied research, and bring to the industry is not an overnight process. It takes 17 years now until to its stage. Thank you very much.
Thank you, Dr. Nugroho. Is there any question from participant? Okay, Arya first.
Yes. Okay. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Let me introduce myself. My name is Arya, and I'm the seventh semester student in UPNVJ Jakarta. My question is, if this ICSOT is used at the harbor, will the cost of a ship to berthing is increased? And if increased, what kind of way for you to convincing harbor to use it instead of the old-fashioned way that has the cheaper cost? Thank you.
Thanks. ICSOT is a software, a loading software, meaning software which assists a planner, chief officer to allocate cargoes on board ship. And the questions will the usage of ICSOT increase the transportation cost, right?
Yes.
So we have conducted a study on it on a few sizes of container ships trading from Jakarta to Makassar back and forth. The size varies from 200 under 600 TEUs capacity. And you know how much does it cost? It costs only 200 rupiahs per box for the computation cost. So 200 rupiahs is cheaper than even the cheapest candy, you know. And so basically it costs nothing. And it shows that the usage of IT is very convincing, that that the benefit is there, and the competition cost is very very low. Thank you.
Thank you, sir.
Okay, thank you. Next from Prof. Ikap first.
Thank you very much, Pak Setio Nugroho. It is a very interesting information for us. At least I can raise 2 points. One, considering the way to increase safety alert among us, among the shipping industries, naval architects, and so on. At the beginning, you showed us a picture of the collapse of container, and also one of the accident with MV Rafaelia in Bali 6 or 7 years ago. And you have introduced the ISO. Actually, you said it about more than 10 years until today.
More than 10 years.
Yes. Do you have any study of the effect of the use of ISO to reduce the accident in terms of, say, a collapse of stability and so on, in particular in Indonesia? That's the first point. The second point, you introduced ISO in education. One picture in Politeknik Bumi Akpelni, and usually they have a simulator. Say when a big boat come to a harbor, say to Jakarta, Singapore, and so on, they can learn how to handle the vessel. What happened with the quality of education when you introduce this to the what do you call Politeknik Bumi Akpelni, for example? And do you consider this should be used by students, say at ITS, UPNVJ, and so on, for the future, to teach us, to the students, that the safety is a very crucial. Thank you, Pak Setio.
Thank you. The first question. The usage of ISO and no usage of learning software on board ship in relation to safety, right? We have conducted numerous surveys on board ship, and we looked into their stability calculations and container manifest of various ships, tankers, bulk carriers, ferries, and also container ships. And the result varies. First, I would like to ask you all, among 4 major types of ships, ferries, containers, bulk carriers, and tankers. Which one is the safest one? Suppose you are going to travel on board ship, on board one of the ship. Which one is the safest one? Which one? Yeah. Which one? Tanker. And container ship? Bulk carrier? Ferries?
Golput.
Okay. So, student first. Why ferry? Okay. Any other responses? Surprisingly, it must be that way. Yes, logically yes, because it transports human lives. But in fact, like both professors, Ranilson and Utama, tanker is the safest one. Why? Because of the ecosystem. The ecosystem in the business of tanker respects very much the regulations, and their stability calculation accurate. And in contrast to it, ferries. The calculations are, when there are poor. In many cases, they do not calculate the stability. You might be surprised of it. You go on board and ask a chief officer, may I take a look at the stability calculation? No. You would like to see the stowage plan? No, only a list of trucks. And they do not know where a certain truck is stowed. For example, B111, a truck with that number. It is on the list, but they do not know where it is located on board ship. Could you imagine how to calculate its stability? You cannot do about it. And it raises our concern. Therefore, we provide one of the versions of our ISO in tablet running on the Android, so that the telemen do not use a carton or a piece of paper writing only a list of cars. And I hope it illustrates my answer to you, right? And secondly, education. Yes, it is used by maritime polytechnics because it is compulsory. The issuance of certificates to the cadets is there, and ISO cargo handling simulator is used for that purpose. And second part of education, university of like here, UPN veteran or ITS or UNHAS or Pattimura, for example, do they require this one? I would like to refrain the things happened around 3-4 years ago. We educate our students in the field of marine transportations. They are working now in shipping companies, at ports, and also logistic companies, and a small part also at classification societies and shipyards. Especially from shipping companies, they came to us and they protested us, and they protested. Pak Setio, I just learned ISO when I arrived at the shipping company, and I just learned later on that ISO was created by you. Why don't you teach us during the lectures when I was a student? And I admitted that it was inappropriate, but I just realized that more that stowage plannings that our graduates work in a shipping company, their job is related to stowage plans, even though they are not moving the boxes on screen directly, but they sometimes, yes, but it is not their main job. But they have to, they should have knowledge about stowage plan. They should have knowledge about the meaning of stability, especially in harsh weather. And since 2 years ago, I decided to donate ISO for my own department, but that was the first. And then it follows with a few other universities. I'm very happy also to announce if this university is interested to have this one. Why not? We have ISTO for types of ship, and the students could also play around with ISTO when the containers are moved on the right side, how what will happen, and so on, and also the ballasting water as well. But basically, that's actually the situation why ISTO is also important in education. But there are two things. For university education, students must have knowledge about the reasoning why in certain loading situation the stability is poor or not poor. But for maritime polytechnics, they should they must operate such a software lively every day for their job, and so the emphasis is somewhat different. But now few universities already use ISTO. Thank you very much.
One more, can I propose, Pak Setio? Well, it is very interesting. Actually, ship stability is a major part of study in marine technology. I agree that you have introduced to your students. So when we talk about this, one of the reference, of course, say basic shape theory from Rosenthapper, and the other one, the ISTO. We should introduce that to all of the university consortium. And it is good if we can offer with a special cost of the software to the university. For example, yesterday I met a professor from England that some of the very expensive software in a CFD actually sold to university at a very special price. So if we pay, say, 2.5 million rupiah, the software for commercial purposes, but for the university, they have to sell it, say, about 3,000 pounds sterling only, with per package with 500 license. There's a regulation now in the UK because the software is used for education, for research, not for commercial purposes. You should think about that. If you sell for commercial purposes, okay, you can say with the standard price. Please consider and then part of the okay, that's my proposal. Okay, thank you, Pak Setio.
Thank you very much. But one thing, we have also a close relationship to Strathclyde University in Glasgow, Dr. Rafet Emekurt, and we discussed last time, and he explicitly mentions that he would like to have ISTO to teach index stability for their students, and we will see. Thank you very much.
Thank you. Thank you. I think this is the last question, Dr. Nugroho, and you can go back, okay. Dr. Nugroho, and thank you. And then I will return to our MC, Happy and Faiz.
A big round of applause for our keynote speaker.
Okay, before we go to the next agenda, there is a plaque giving season for the keynote speaker. The first plaque is given to Mr. Chris Booth, which is represented by Prof. Iketut Arya Priyotama. To Prof. Iketut Arya Priyotama, please join with us. And for Mr. Fahri, please to welcome to give the plaque.
Next year when I get the headquarters, I will pass it to you. Okay, thank you.
Thank you very much. Thank you.
Okay, congratulations to Mr. Chris Booth, and thank you to Prof. Iketut Arya Priyotama. The second plaque is given to Martin Renelsian. To Prof. Martin Renelsian, please join with us. Congratulations and thank you to Prof. Martin Renelsian. For the third plaque is given to Dr. Ing Insinyur Setyonugroho. To Dr. Ing Insinyur Setyonugroho, please welcome to with me. Congratulations and thank you to Dr. Once again, give a big round of applause to our keynote speaker. Okay. And also prayer for a Muslim in the mosque near a faculty of medicine. We kindly ask you to return promptly at the schedule of 1 p.m. because at the time, we will start the next session that is parallel sit-in Dewan.
Bon appetit and thank you for attending. For the audience, maybe can
Thank you very much.
Okay, Mr. Denny, can you try to share your screen now?
Yes.
Test.
Okay. Is it read it?
Yes, I can see it. Can you full view?
Yeah.
Okay, before you start, I will is moderator start the parallel session.
Okay, thank you, Pak Fahri. I want to start next session. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen. Welcome back all participants and the speaker in the second session. That is the parallel session day 1 on International Conference on Ship and Offshore Technology 2023, or we can call it ICSOT 2023. In here, my name is Fatin Muhammad Mahdudu. You can call me Fatin. I am young lecturer in UPNVJ Jakarta. And it is great honor and pleasure for me to welcome all the participants in here in this big event. And I want to give information that in this event is conducted in a hybrid setting. So I would like to welcome all participants that joining us virtually. Maybe I hope you all well in the online settings. So to minimize timing consuming, I would like to start our presentation from the speakers. Number 1, with name is Mr. Dani Imam Santoso,
Yes.
Mr. Ato Setiawan, and Mr. Bambang Sudarmanta, with title of The Possibility of Hydrogen Gas as the Main Fuel or Diesel for Diesel Engines, a review. So time and place is your Mr. Dani Imam Santoso.
Okay, thank you, Mr. Fatih. And thank you for the opportunities that have given to us. Good afternoon. My name is Dani Iman Santoso. As presenter and represents the authors, we will present our review about the possibility of hydrogen gas as the main fuel for diesel engines. Many articles have discussed about this before, but the topic is still up to date due to the net zero emission policy in 2050 that mandatory for transportation sector to reduce their carbon emissions. Okay. It change. We began with Santoso et al. Research in 2003 that they introduced hydrogen at the 50, 90, and 97% by volume to the diesel combustion chamber. They flow hydrogen into intake manifold to make homogeneous mixture with the air. The engine speed and load are constant at 2000 RPM and 10 Newton meters respectively. From the indicated efficiency graphs, we can say the more concentration of the hydrogen, the lower efficiency can occur. If we see on cylinder pressure and heat release rate graphs, we can know that the more concentration of hydrogen makes the lower graphs. We go to Das et al. Research in 2020. They varied engine load at 30, 60, 80, 90, and 100%. They just added hydrogen at 2 capacity, 7 and 10 LPM. They used diesel and biodiesel blend that call it P20. From the BTA graphs, from the BTA graphs, you can see for all combination of fuels, the engine load 90% have the highest BTE. From this, we can make little conclusion that for little concentration of hydrogen, high engine load gives better BTE. From the cylinder pressure and heat release rate graphs in full load, we can conclude that diesel with addition of 10 LPM hydrogen gives the lowest value. It indicates that the highest engine load makes the lowest cylinder pressure and heat release rate for 10 LPM hydrogen capacity. And for all the emission graphs, engine with fully load gives the highest gas emissions for almost all combination. It can indicate that engine with full load release more exhaust gases because it needs more energy to run. We go to Bakar et al. Research in 2022. More complex situation than two research in the beginning. They ran engine diesel fuel and hydrogen addition with capacity until 97%, same as Santoso et al. But they varied engine speeds and loads. The variations of engine speeds are 1500, 2000, and 2500 RPM. And for engine loads are 5 Newton meters until 25 Newton meter with the step every 5 Newton meter. From the BTE graphs, we can see that for lower engine speed, the high engine load produce knocking. Even the hydrogen capacity is low. For engine with the high speed, knocking occurs just in fully load with moderate hydrogen capacity. And from the cylinder pressure graphs, it indicates that the higher capacity of hydrogen makes lower cylinder pressure for all variation of engine load. And the exhaust gas emissions and the exhaust gas emissions graphs describe that higher engine loads produce higher gas emissions. For the conclusions, can say that it was possible to make hydrogen gas as the main fuel of diesel engine, but we have to know the operation condition to avoid knocking. For all the results from the three researchers, the hydrogen entered combustion chamber through intake manifold. It can give different conditions if hydrogen gas enter combustion chamber via injection port. Thank you for your attention.
Okay, thank you, Mr. Dani. Okay, I forget to tell you about our rules. For the presenter, you can deliver your presentation for about 10 minutes, and after that, we can discussing and Q&A for about 10 minutes. And thank you, Mr. Dani. So the next, there is some question from audience. If you have question, you can raise your hand. Okay, Mr. Professor.
Thank you very much for a nice presentation on a very interesting topic.
Yes.
I noticed your first point is possible to replace diesel by hydrogen. Do you think that's, maybe I didn't quite understand some of the technicalities because that's not my field, but just the conclusion is that the way people are going to go? Are people going to replace diesel by hydrogen in an internal combustion engine? Is that the future?
From the researchers that I present, the hydrogen enter the combustion chamber via intake manifold. The hydrogen mixture with air to make homogeneous mixture. Then it will inject it into combustion chamber. Maybe in the future we can give injection port, another injection port besides the diesel fuel port, to make hydrogen more useful to give high efficiency. Like that, Professor.
Thank you. And
Yep.
think that's the future? Is that what people are going to do in the future?
Yes.
Yeah, well, I wish you luck. That sounds very interesting.
Yeah.
Thank you.
Thank you.
Thank you, Mr. Dani. Is there any questions more? I would like to ask one question.
Yep.
Mr. Dani. Is there any special treatment for replacing the diesel engine by hydrogens in the engines? Is there any special treatment?
Yeah. In the currently it enter the hydrogen in the two two ways, that intake manifold and injection port. But from until now, hydrogen capacity still lower, like 10 lpm or 5 lpm. So maybe in the future we can give more capacity of hydrogen, like in 90% of or 95%, and we just need little diesel fuel just to give beginning of the ignition from the for the ignition, just like that. So the diesel fuel just to make ignition in the beginning. Then when the combustion chamber still enough hot, the hydrogen can be combusted by itself, like that, Mr. Fatih.
Okay, thank you, Mr. Dani, as for your explanation. Maybe if there is no question, okay, Pak Fajri.
Okay, thank you, Mr. Dani.
Yes.
I want to ask you about your opinion. Why in Indonesia the use of hydrogen not massive? We still use diesel. Why? From your opinion. Thank you.
Yes. I think from my opinion, the hydrogen people use gas fuel like hydrogen is more dangerous before then we use liquid fuel like diesel or biodiesel. So it will give more tool to make this safety, like that. So hydrogen is more dangerous, more can be spoiled, can be boom, like that. If we can treat, if we cannot treatment in the good way, like that, Mister.
Your concern is about the safety.
Yes.
Of hydrogen. Okay, thank you.
Yeah, thank you.
Fajri, okay, I think that is enough for our first presenter. Thank you, Mr. Dani, for your presentation.
Thank you, Mr. Fatih.
So you can close your slides and we move on to the second presenter. That is Mr. Karyawan, Mr. Sayuti Samsuar, Mr. Yudiawan Fajar Kusuma, and so on, with title of Investigation of Spiration Effect on Catamaran Floater Resistance. Is there Mr. Karyawan in here? I say again, is Mr. Karyawan with me? Okay, I call it again for the second calling. Is Mr. Karyawan in online chat room or in here? I think in here is not. Okay, last calling. Is there Mr. Karyawan in online room or Zoom room? Okay. If there is not Mr. Karyawan, we can move on to the third participant, that is Mr. Muhammad Hanif Mudafar and Mr. Muhammad Arif Budianto, with title comparative analysis of emission using biodiesel fuel in medium speed diesel engine using simulation method. For the Mr. Muhammad Hanif Mudaffar or Mr. Muhammad Arif Budianto, time is yours.
Okay, can I share screen on my device or yours?
Yeah, sure, sure.
All right. Okay. Assalamualaikum warahmatullahi wabarakatuh. Allow me to reintroduce myself. My name is Muhammad Hanif Muzaffar, and today I'm going to present my research and my college research about comparative analysis of emission using biodiesel fuel in medium-speed diesel engine using simulation methods. Now, for the introduction, in the recent years, the implementation of environmental emission reduction regulation, particularly from MARPOL Annex number 6, has driven government and ship owners to seek environmentally friendly alternatives. Now, in Indonesia, based on Minister of Energy and Mineral Resource Regulation number 12 of 2015, and it continues to be updated until now, biodiesel B30 is being implemented. With the hope of this, biodiesel could be an alternative for fossil fuel or a solution for environmental emission reduction. Now, the question arises is whether biodiesel can be a solution to reduce environmental emissions and could have an advantage in its use as an alternative fuel and does not have a negative impact that are worrying for the industry. Now, for the fuel analysis, we're going to divide it into two different analyses, which is engine efficiency, which is necessary to analyze engine efficiency using biodiesel fuel to determine whether biodiesel can provide a good performance in terms of brake power and fuel consumption. Now, for the emissions, we're going to analyze the NOx emissions, CO2 emissions, and SO2 emissions that can provide information about environmental impacts of the biodiesel itself. Now, for the objective of this paper, we can analyze the emission from the ship engine using biodiesel to aims to understand the effectiveness of the sustainability potential of biodiesel, blended diesel for the shipping industry, and to compare which biodiesel give the most increase in performance while lowering environmental emissions in the engine. Now, these are the flow diagram of the research methods. Now, for the software that we're going to use are Diesel RK or DRK, we could call it like that. DRK is created in Russia. It is a software that could simulate data and incorporating variables such as fuel physical properties and engine specification. The software was to serve as a more effective tool for simulating or optimizing combustion engines with engine parameters, emphasizing the refinement of mathematical models and algorithms. For the diesel aircraft software involved the integration of advanced mathematical models to accurately depict the combustion process in diesel engines. The software meets the diesel injection characteristic and precision of the fuel atomizing, development of fuel spray dynamics, and also accounting the emission of NO is achieved by Zeldovich mechanism. And below there, we can see the requirement of the mathematical models and the Zeldovich mechanism that are needed to have a result in this simulation. Now, the data that was needed to simulate this research was fuel physical characteristic, that is, we're going to use heavy fuel oil, biodiesel B10, B20, B40, B60, B80, B100. Now, for the engine specification, we're going to use an engine with 1000 RPM with 4-stroke cycle and water cooling system. Now, for the engine specification input windows, we could input the necessary engine specification requirement. Then we're going to input it with engine speed for about 350 RPM, 400 RPM, 500 RPM, up until 1000 RPM. Now, for the fuel characteristic, we can input it on the fuel selection and fuel specification window. After that, we could execute the simulation program, and then we could have the result, which is we're going to compare every biodiesel blends and heavy fuel oil. Now, for the result, for the brake power, all biodiesel have an increased brake power, which the highest increase are from biodiesel B20, which have an increase of 8.18%, while for the lowest increase are from biodiesel B100, which is 0.25%. Now, one of the main factors influencing energy content is the caloric value of the fuel. Biodiesel has a higher calorific fuel than heavy fuel oil. Thus, caloric value represents the amount of energy produced by combustion of a fuel. The higher the caloric value, the more energy that can be generated by burning that fuel. Now, for the specific fuel consumption, biodiesel have a decrease and also have an increase. Now, for the decrease, only biodiesel B10 and B20 that have a decrease, with the highest decrease are from B10, which is 4.83%. Now, the lowest decrease are from B20, that is 3.44%. Now, whereas for B40 up until B100 have an increase, which up to 21.48%. The reasons why biodiesel B40, B60, B80, and B100 have a higher specific fuel consumption compared to heavy fuel oils due to the lower heating value from the biodiesel itself compared to heavy fuel oil. The lower the heating value may have a result in higher specific fuel consumption during combustion. Now, for the CO2 emissions, all of biodiesel have a significant decrease, by the highest decrease by B20, which is 5.68%, and the lowest are B100, which is 0.05%. The decrease are caused by the greater oxygen content rather than heavy fuel oil. The higher oxygen content available for combustion can promote more efficient combustion, resulting in lower CO2 emissions. Now, for SO2 emissions, which have a great and significant decrease, which up to 99%, with the highest decrease is by biodiesel B10, which is 99.8%. And then the lowest was still 90% still, which is biodiesel B100, was decreased for about 98.7%. The reasons for this significant decrease was due to sulfur fraction in the fuel sample. Now, for biodiesel, have little to no sulfur fraction in the fuel itself, whereas for heavy fuel oil contains higher sulfur content, thus having a lot of more sulfur emissions rather than biodiesel. Now, for the NOx emissions, have a very increasing emissions. Because of this, there's a lot of factors that could affect the NOx emissions, which are one of which are the oxygen content in biodiesel, which provides additional oxygen for the NOx formation. Because of it is known that NOx emissions are related to the start of combustion and the heat released during combustion. Early combustion initiation leads to higher cylinder pressure and higher combustion temperature, resulting in higher NOx emissions. Now, for the NOx emission and how to lower it, the increasing was a major disadvantage, we could say that. The reasons on how NOx was increased was due to a lot of factors, as stated before, one of which are mass composition of the fuel itself, like oxygen content of the biodiesel, and also the fuel injection timing. Research suggests that by delaying the fuel injection timing in combustion may have a result in decreasing NOx. However, due to a delayed injection timing could also cause an increase of specific fuel consumption and an increase of CO emissions. Now, for the effect on biodiesel in engine, one research suggests that using biodiesel can speed up the replacement of the fuel filtration, which cause a possibility of blockage on the surface of the filter. Because the higher the biodiesel mixing ratio used in the engine operation, the greater the potential for filter blockage. The filtration turnover rate becomes faster. Now, for instance, the filter surface in the contact with the biodiesel is predominantly covered by oil sludge in the form of slime. This shows that fatty acid content in the biodiesel is high and form polluting compound that easily becomes gel. This is due to its low oxidation stability, so it's easy to crystallize and become solid. Now, for the conclusion of this research, B20 are the most viable biodiesel fuel among B10, B40, B60, B80, and B100, showing the most significant improvement compared to other biodiesel blend, with an 8.18% increase in power and a 3.44% decrease in specific fuel consumption. Now for the now for the emissions, B10 has the most positive impact on reducing environmental emissions compared to other fuels, with a reduction of SO2 and CO2 emissions by 99.89% and 5.8%. However, in terms of NOx emissions, all biodiesel have significantly increased compared to heavy fuel oil. Now, for the NOx emission, there is a need to develop further strategies to reduce NOx emission in biodiesel without increasing specific fuel consumption or other disadvantages such as CO emissions. Now, for further research is required to analyze the effect of biodiesel use in ship engine components. It is hoped that understanding this effect of biodiesel use on engine components can serve as a reference for further research on the advantage and disadvantage of biodiesel in ship engines. I think that will be all for my presentation today. Thank you.
Okay, thank you, Mr. Hanif. So, is there any question related to the Mr. Hanif presentation?
Okay, thank you very much. Interesting subject. In the conclusions, you mentioned that the CO2 emissions for the biodiesel is 4.9%. Is that right? 4.9% reductions of emission of carbon dioxide. Do you? Sorry.
Yes. Pardon.
4.9. Yes, correct.
5.98%.
Sorry, 5.9. 5.9% reduction in CO2 emission. So just checking if you compare that, for example, with engine using non-biodiesel, but installing scrubber. What is the CO2 effect? I mean, for example, if I were the owner, then with all the disadvantage of the biodiesels for my engine, I would put on scrubber rather than change into biodiesel, for example. What do you think? Is it still better option to fully use biodiesels or compared to, for example, engine with scrubber?
I think with using scrubbers are more effective rather than using biodiesel, because I don't know the specific decrease in using scrubber versus using biodiesel, but some research and my college told me that using scrubber could have a major impact in emissions, such as for SO2 and CO2 emissions. Okay,
Is it answer your question, sir?
So is still uncertain whether, for example, comparing with the putting scrubbers onto the engine, or is it still? But based on your experience, based on your knowledge on the biodiesel, what is the prospect of using biodiesel in the long terms? Is all the owners, ship owners, for example, is going to attract using biodiesel, or they would wait and opt to install scrubber instead? What do you think?
I think by using 100% biodiesel could not be a sustainable thing to do. It still have to be used as a biodiesel diesel blended, like B20 or B80 maybe. So yeah, it is still I could say it's still unsustainable for this year, maybe in the future.
Okay, thank you.
Yeah.
Thank you, Mr. Rika. So is there any other questions? Oh, Azri?
Okay. Thank you, Mr. Hanif. I have two questions. The first question, why in your simulation you not consider carbon monoxide? Because carbon monoxide in combustion engine is one of the high hazard. And the second question is your simulation, did you do validation in your simulation? Because what I see is only simulation data, not you not comparing to the someone experimental data. Okay, thank you.
Okay, thank you for your question. Now, for the first question, I will consider to use carbon monoxide for the next research. Now, for the second question is, do I validate my results to another person paper? Is that right?
Yes, it's correct, sir.
Oh, okay. In some research have used diesel aircraft simulation, and most of them have a different opinion in the results, but there is still some of them that are still in line with my results. So yeah.
To answer your question, Mr. Fajri. Thank you. Is there any other questions for Mr. No? Okay. Actually, I have one question, sir. If it's still 2 minutes left. As I know that in biodiesel, even B10, B20, B30, is there some feedstock, you know, the basic, like as I know in Indonesia, B20 using the palm oil is correct, right? And in other countries like Brazil, as I know, there's some another plants that they're using. So my question is there any differences between the plant that we use? For example, I use the palm oil and another country using another plant.
Yeah, there's a lot of different physical properties when using different vegetables, such as maybe soybean or maybe crude palm or maybe rapeseed. Am I correct?
Yes.
Yeah, there's a lot of different effect in physical properties.
So it can affect the.
Yeah, it could affect the result of the emissions and.
Okay, I see. Okay, thank you, Mr. Budafar. I think that is enough for the presentation, and we can move to next presentation. I have some message from the committee that the previous speaker for Mr. Karyawan is already in Zoom meeting. Is it correct, Mr. Fahri?
Yes. Mr. Bagio Suasono, can you hear me?
Yeah.
Mr. Bagio Suasono?
Yeah, okay.
But you presented your research now?
Next presentation, and my colleague, Mr. Karyawan,
yes,
because not join this time.
No,
Maybe you exchange next to Mr. Muhammad Arif Budiono.
Okay.
Mr. Karyawan is not join, and be prepared to join. I'm so sorry. You can next to Mr. Muhammad Arif present this time.
So I think now it's better to move to paper ID 13.
Okay.
With the name Mr. Fajri Raihan, Andika Masrul, Arya Khairullah Akbar, and Bima Nugrah Putra.
Okay.
Please.
The title of the numerical study on the seakeeping performance of step-out planning hull under astern and abeam wave conditions. For the Mr. Fajri Raihan, or Andika Masrul or Mr. Arya Khairullah Akbar and Bima Anugrah. So time is yours. Yes, okay. Okay, Assalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam.
Good afternoon to all of the participants for ICSOT in 2023. My name is Bima Anugrah Putra. I'm an undergraduate student from Naval Architecture at UPNVJ Jakarta. Currently, I'm in my 7th semester. So today I want to presenting our study, which titled Numerical Study on the Seakeeping Performance of Step Planning Hull under Stern and Beam Wave Conditions. So let's next move to the introduction, please.
Waalaikumsalam, kok belum join dipanggil-panggil.
Saya juga sama Mas Ayubnya itu.
Sorry, Mr.
Okay, let's continue the introduction. Yeah, speed is one of the most crucial aspect for designing a ship. So with higher speed, we can transport any other that is with shorter amount of time. But speeding has its own consequences, especially instability, arising from vertical transfer wave or a combination of it. So when the ship is speeding, it has a consequence of its stability, intend to capsize or else. So movement from the waves can lead to damage and discomfort for the ship. Next slide, please. Okay, now it's step planning hull. Step hull is modified ship with elongated concave surface on its bottom. So the purpose of this concave is to reduce the contact of water surface area. So when the ship is moving forward, the air is going inside of the concave. So it lifts a little bit of the hull and the water surface area is decreasing. Next slide, please. For the ship stability, we're using these three main formula. One is RAO for transition movement, RAO for rotational movement, and encountering wave frequency. So this is the example of 6 degrees of freedom in the ship stability of or ship movement. Next slide, please. The methodology were used in the study. The study was conducted by using appropriate supporting data from previous study by Najafi at 2020. Data encompassing ship's response and factors contributing to variation were also collected. So this is the total of model scale main dimension. Next slide, please. Step hull was modeled using massive software, starting with hull prototype. And it should be noted that step hull with rest angle were manipulated in some models. 3 configurations were established varying in step hull length, dead rest angle, and step angle. Next slide, please. So this is the results of our study. Sorry for the inappropriate size of the font or the graphic. Based on the figure, significant difference was evident in the pitch motion. So this is the 5 graphic based on this 5 model of configuration. All of the graphic is showing that the peak is only at pitch condition. It's because when the wave comes from astern or front of the ship, it obviously will rotating the ship to trim forward and backward. So the result, it is the frequency range from 0 to 0.8 Hertz, the RO is increasing. And beyond 0.8 to at 2014, so ships may be constant at the specific wave frequency, and it will become stabilized. Next slide, please. So in another figure showed significant difference were observed in RO values for the roll motion of ship when wave comes from the side of the ship. So it likes previous graphic. when the wave come from side of the ship, it obviously will rotating the ship in a rolling way. But the difference is the spanning between 0 to peak of the RAO is spanning at 0 to 1.2 hertz. Based on this observation, achieving a constant RAO is required to higher than 1.2 hertz. Right, please. So all of the previous figures showed that the most configuration exhibits similar RAO response. However, one configuration stood out, producing the highest rolling value and the highest pitch value. So the highest is from the configuration number 3, step hull with 240 degrees, sorry. So it's showing 1,287 degree per meter, indicate a significant of capsize tendency. But in the opposite, WO/S20 configuration with wave coming from Aston showed the best RAO response, being the lowest or closest to 0. So this is the graphic with the best RAO value. Next slide, please. And so this is the conclusions of our study. In conclusion, the study found a significant difference in the ship's pitch and roll movement. Based on the direction of the wave, the trip step hull configuration had the highest rolling value when wave from the S side in WO/S configuration was most stable when wave came from behind. Overall, ship without steps were more stable than those with step, given the same main dimension. So that's all for my presentation. Thank you.
Thank you, Mr. Fajri. I want to re-inform if there is some question from the who joining us virtually. You can type your question into the chat room. Thank you. Is there any question? Pak Fajri and Professor.
Thank you very much for a very interesting presentation. Unfortunately, I couldn't quite make out all the information on the figures, but I have two questions for you, really. The first question is, you were representing the RAOs, which are the linear response. And my question really is whether you have any indication of any nonlinear motion response for a small planing hull. There might very well be, and I just wondered if you knew about that, or if you were able to have information on the nonlinear response. And the other question I have for you is regarding the stepped hull. The stepped hull, one of the reasons for having a stepped hull is it helps with the longitudinal stability, doesn't it? It helps with the pitch stability when you're going very fast. Did you have any knowledge about the effect of the stepped hull versus the conventional hull regarding longitudinal stability? Because you were talking about transverse stability, but we have longitudinal stability as well. Thank you.
So I'll answer, thank you for the question. So I'll answer the first question about nonlinear RAO. I'm sorry, but we're not studying about nonlinear RAO for this study. We're just study about linear RAO in ANSYS Aqua. But sorry, we're not studying about nonlinear RAO. But for the second question, is step hull is tend to trimming backward when they move at higher speed. So when it moves backward, the center of gravity will moving also backwards. So it will have a tendency to have higher at rolling or pitch movement, because the center of gravity is moving than any other conventional hull, which is maybe the center of gravity is located at the exactly center of the hull, but on the step hull, the center of gravity will moving rear backwards. I think it's my answer. Thank you.
Is it answering question, sir?
Yes, yeah,
Okay.
no, I think, do you mean center of buoyancy or moving, not center of gravity? When the plane, the vessel is changing, the
Yeah.
center of gravity won't move. The center of buoyancy, do you mean?
But as I know, it's center of gravity because the geometry of ships is really moving backwards. It's streaming in the backwards position.
Thank you.
Enough, sir?
Perhaps it's my English. And
yeah, I understand.
can talk later.
Okay, I think it can be moved to Mr. Fajri. Mr. Fajri, it's time is yours.
Okay, this is I will ask question to myself ya, Mr. Fajri. Fajri as Fajri. Okay, Mr. Fajri. I want your opinion. What is the best RAO data from step planning hull with monohull or non-step hull catamaran? In your opinion, what is the best RAO?
Oh,
thank you, Mr.
Okay.
Fajri.
Thanks for your question. I think the area value between the monohull with step hull or the conventional hull but with catamaran model, the area value for catamaran is definitely better. So because it doesn't have the step which will decreasing the atau or moving the center of gravity rear backwards because it's conventional, and for the roll movement because mostly catamaran have a wider beam length, so it can stabilize the ships better in the rolling motion. Thank you.
Is enough, Mr. Fajri? Okay, thank you. Is there any question from the room chat, Mr. Diki? Is there any question? No? How about in this audience? Is there Mr.
Okay, good afternoon. My name is Mahendra, called Hendra. I have a simple question. What the type of wave spectrum in used in this research? Wave type wave spectrum, or for example is apa? Yeah. For example is apa sih? Jones Web or etc. Okay, thanks.
You get your spectrum, what is?
Okay. Thank you for your question, but sorry, I will answer it, but with knowledge you know. So the spectrum is we're using only based on ANSYS Aqua. We're not setting any personal preference. We're using default setting from ANSYS Aqua. So I don't know the exactly spectrum we're using for the study. Thank you.
Is it enough, sir? Okay, thank you. Okay, I think that is all the presentation from Mr. Fajri. Thank you for your time.
Okay.
Is there any quotes or?
Okay, so sorry for my bad presentation or anything else. Good afternoon, everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Mr. Fajri. Okay. For Mr. Fahri, how about Mr. Karyawan? Is it okay for the next presentation? Or we move on to the Mr. Airlangga?
Maybe we can move on to the next
Mr. Airlangga.
paper. Yes, is paper
Okay.
number
32, right?
32.
Okay. The next paper is from Mr. Airlangga Ricard Harsono Putra, Mr. Fahri Akbar Ayub, Mr. Ramadan Farhan Fadila, and Mr. Wiwin Sulistiawati. The title is Speed Analysis of Catamaran Vessel using Center Bulb as a component of ship resistance reduction. Maybe for Mr. Erlangga, is it correct for the presenter? Is there Mr. Erlangga? Or oh, Mr. Farhan? Okay, Mr. Farhan Fadila. Yeah, time is yours. Papernya ada, Pak. Presentasi ada. Episode 32.
Yes. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. I will introduce myself. My name is Ramadan Farhan. I'm a 5-semester student, and the study is speed analysis of catamaran vessel using center bulb as a component of ship resistance reduction. Next slide. Okay, this is a summary of this. Catamaran is double ship. It's the main definition of is their advantage and disadvantage compared to the previous one. Theoretically, catamaran have better stability, but more significant resistance because of waves hitting the hull. One of the solution is to add center bulb. In this study, the center bulb, which function to decrease the ship resistance, was varied in shape, position, and speed. The shape used is foil shape Naka 0030 with 2 different x-axis position and 5 speed from medium to high. In this study, there is an analysis of fluid flow and wave interference between the two hulls to show the most efficient speed and decrease in shape resistance through axis CFX. Next. Okay. Now, background research. Okay, why do we choose these studies? First is catamaran is one of the trend in the shipbuilding industry. If you go to island, let's say Aceh, Sabang island, the connecting ship is using catamaran because it's more cost effective right now and have less resistance. So it's become trend nowadays. Second is resistance of catamaran is less compared to monohull within the same displacement. So it's economically efficient from financial perspective. And resistance could increase the operating cost of the catamaran and decrease the performance of catamarans. Next. So this is the problem formulation. How do we 3D modeling center bulb in catamarans? The second is, how does the center bulb positioning and ship velocity affect the resistance? And what is the idle speed and configuration for the catamarans? Okay, next. Now, there is several benefit of this research. The first is to reducing resistance from catamarans. Second is gives data-driven decision making whether to add center bulb or not. And third is give the optimal configuration of speed and center bulb variation of catamaran. Now, there is a limitation of this study. First is that we only use a NACA 0030 for the shape of the center bulb. Second is the speed only varies from, there is a little bit mistake from 0.15 to 0.30 with the increment of 0.5. Ship motion and maneuvering aren't being considered, so we don't study the sea keeping and the motion of this catamaran, and the structural strength of both ship and center bulb aren't being considered. Okay, next. Hypothesis. The hypothesis is that center bulb will interfere with the waves, thus reducing the resistance, and center bulb will efficiently reduce resistance, especially at high speed. Okay, next. Now, center bulb is an innovation in ship components, especially in catamaran ship. So the component primarily intends to reduce wake resistance due to fraction of waves from the center of two catamaran hulls. Next is resistance is fluid force that resists motion in opposite direction, and catamarans all hull form with this feature that has two hulls known as multi-hulls. Next. Now there is several data that used for the base of the research. First is next. First is the 3D model. In the corner upper left, there is the 3D model of the ship, and then in the corner upper right, there is a NACA 0030. In the corner bottom left, there is a center bulb horizontal arrangement. We use two center bulb arrangement. First is in the front, and the second is in the mid. And third is center bulb vertical arrangement, which we make that it's all linear. Next. Now, the main dimension of the model that being simulated is first length of overall it's 0.91 meter, beam of overall it's 0.11 meter, and height it's a 0.08 meter, and draft it's 0.035 meters. Next. So this is the result. So first, it's noble persistent as a benchmark or a base of this research. So we see that they tend to increase the resistance along with the speed, but there is anomalies in the 0.3 velocities. We find that instead of increasing the resistance, they actually reduce the resistance to 0.477. Before is 0.612. Next. Now, the first configuration is mid bulb persistent. Now we see in this graph that it's differ from the first or benchmark with no bulb. That's it's actually always increasing and not decreasing in the 0.3 speed Froude number. So there is some anomalies in there. Next. And in front bulb persistent, so behave samely with the mid bulb variant. It's always increasing within the increase of the speed. So from 0.618 to 0.871. Next. Now we compare the resistance, and then we see that it shows that the no bulb persistent is indeed behave irregularly compared to the front bulb and mid bulb variation. Okay, next. Now, first is that positive value mean there is a reduction, and negative value mean there is a reduction. So we found that the front bulb did not reduce any resistance whatsoever. The only center bulb variation that reduce the resistance is only the mid bulb in a 0.15 Froude number, and in 0.25 Froude number, they decrease 15 and 16%. Next. Now, the conclusion is the best position configuration and effective speed from several variations that have been simulated is position in mid, which is the coordinate of 0, 45, 0, 0.5 at speed of 0.5 Froude number and 0.25 Froude number with direct value of 0.199 and 0.518 Newton respectively, worth of 15 to 16 reduction in catamaran ship drag. Number 2 is the effect of shape, position, and speed variation on the catamaran ship model research using the center bulb can be described as follows. The effect of center bulb position provide less direct value, especially at the mid position, because it can reduce wave interference caused by both holes. The structural strength of the center bulb is not considered in the study, so it needs to be further analyzed for the application of center bulb on catamaran ship. The study did not add the shape of shaft and propeller, so it needs to be so further research is needed, and conduct further research to analyze the direction of center bulb angel tag to reduce drag by conducting direct experiment to validate the research result. Okay, that's all from me. Thank you. Back to moderator.
Thank you, Mr. Farhan, for your presentation. I would like to ask is there any question from virtual, Mr. Digi? No? No, right? No? Okay. I would like to ask, is there any question in this room, audience? Okay, Professor Nelson?
Thank you very much. Yeah, I don't understand the geometry. There's something. Can you go back to the picture of the geometry?
Okay, sure.
Mr. Digi, can you help? Or Mr. Fahri? Can you share screen 8 again? Okay, nice. Thank you.
Okay,
yes, that picture.
The design.
So, so this is this the center bulb in the middle?
Yes. No. The what you're referring, the bottom corner left, right, or
Can is it possible to point to where is the center bulb? What
the shape of the center bulb is this Naka 0013, and then the center bulb arrangement. That means the first variation is in mid like this, and then in the front like this.
So in the plan view, that's it there?
No, it's so catamaran have two holes, like, and they connected by a bridge. So the bulb is in the bridge, not in the hole itself.
Yes, so that comes down into the water.
Yes, that's come down into water.
Oh, that's very novel. I've never seen that before. So that's I couldn't understand the geometry, but now I do. And presumably that NACA section, the leading edge is on the left-hand side.
Sorry?
Which way does the flow over that?
It's flow from the aft to it's flow from the front. So the inlet is.
But that drawing there is the plan view.
This is a side view, and this is
the one view. Above. The one above is a plan.
One above is isometric.
The one on the right is a plan view, looking down.
This one?
No, above.
Above. No. It's yes, plan view, but only limited to the center bulb.
Yes, the center bulb, and the front is on the left hand side.
Yes.
Yes. Whereas below the front is on the right hand side.
Yeah.
Yeah. So I was confused. But so that bulb, it extends all the way down. It's like a
Yes, it's stems down.
like a strut or
Yes, kind of like a nail.
Ah, right, like a nail. Yeah,
Yeah, yeah.
Oh, that's very interesting. And how did you do the analysis? I didn't understand how they.
So the analysis it's using CFX. First we obviously
CFX, yeah,
mass, then we use the default solver in the CFX.
With a free surface?
No, we mass the surface first, and then we calculate. Then we take the conclusion from that simulation.
Oh, that was very interesting, very novel idea. I've never come across it before. It's interesting that you found some cases where the resistance was less.
Yes, but only N2 speed. So there's a reduction at 15 and 16% at at 0.15 and 0.25, but the other ones it's increasing.
Yes, but you've only tried the one bulb. I mean, what you're suggesting is a lot more research needs to be done. The fact you can find something that reduces the resistance only by a little work, you could do a lot more work and find better.
Certainly, we could vary the shape. We could add another shape, another NECA. We could vary.
Or you could make it bigger or smaller.
Yes.
Yeah, lots of them. Very interesting. Very interesting. Thank you.
Okay, thank you.
Thank you. Is there any question? Okay, Mr. Fajri Green. Or from the student, is there any other student maybe?
Thank you, Farhan, for the presentation. Before I ask you question, I have suggestion for your graph. Maybe you can show the graph.
The what? Sorry.
The graph. Graph.
Okay. Next slide.
Okay. The comment from me is the graph too ambigu because there is a dark blue, blue and gray. My suggestion is for the next presentation, you use red, yellow, green, so the someone see different. I see from here blue, 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 and blue.
Okay.
Maybe this is a correction. And this is the question. Why you use NACA 0030 and what is means 0030? Thank you.
So NACA, it's something that's created by NASA. So why I choose 0013? Because there is no others research that choose this particular shape. So that I choose this to view to search what will happen if we choose this particular shape. And second is what mean it's 0013? It's mean that it have 30 millimeters, 30 diameters of its shape. Thank you.
Is it clear, Mr. Fajri? Okay. Is there any other question? Okay, Rika.
Okay, thank you. This is very interesting presentation. That's what Professor Nielsen mentioned. So, but also interesting to see that anomaly is on 0.3 fruit number.
Yes.
I was wondering what would happen if, for example, you increase that into 0.35, whether there is a continuous downward or is there any upward curve again? So we may not know whether that is anomaly or that is only 1 point in a blue moon. You know, it's like maybe it's like.
So the result that we find is that it's actually reducing. So actually we calculated to 0.40, but the reason why we do not include that because it's not realistically enough in a real case because 0.35 and 0.14 will be around 35 knots, which is currently not achievable by most of catamaran ship.
So on 0.3 is related to what speed?
0.3 it's around 25 knots.
Okay, so just out of curiosity, if you increase to 0.35, is it up, back up, or is it further down?
Is it going down? And if I remember,
Yeah.
is it going up, but not by a lot? It's around 0.5 to 5.3, something like that.
So just for the sake of discussion, so if you put 0.35, total force would be 0.5 or
5.1, 5.2, something like that.
okay. Interesting. Okay.
It just seems, is that the force in newtons, 0.477?
Yes, the force is in newtons, not in kilonewtons.
But that's no force at all.
I'm sorry?
Very small. For a full-size vessel?
No. It's not a full-size vessel. It's what's a model with length of less than a meter.
Ah, I see. Doesn't make 0.477.
Yeah. It's not correct. But the rest three is correct. That's one wrong. Check it.
Yes, I did recheck it, but it's always come out. I ran the simulation.
No. Just adding these numbers.
This number.
Yes. I understand you, meaning that's the total resistance should be the sum of the two resistance before, right? But when I calculated through CFX, the result always come up. So I mark it as anomaly, and I think it's interesting to bring up this anomaly into this discussion.
But that is very extreme anomaly, because all of those trees, the total is adding up. They are all added up, and except for those 0.3.
Yes, that's what
I
cannot.
You mentioned as anomalies.
Yes, that's why I mentioned it as anomaly. I already realized it, but I cannot find why this is happening in the first place. So I bring this up to show you that maybe there's something that we don't know. Maybe it's faulty on my side. Maybe there's fault somewhere. It's interesting enough.
Okay, interesting.
This is with no bulb, yes.
For the answer, this is, I think, a very interesting issue. But if we look to the time, I think the time is over. So we can move to the next presentation. You can give the
Thank you
floor
very
to
much.
Mr. Farhan.
And I would like to apologize if there's something wrong. Thank you much.
Thank you, Mr. Farhan, for your time. We can move to the next presentation. Yes, Mr. Farhan.
Mr. Karyawan, can you hear me?
It's already in here.
Mr. Karyawan, can you hear me?
Yes,
Mr.
I can hear you.
Okay. Maybe the next is yours. Are you ready, Mr. Karyawan, for your presentation?
Yes.
Okay. Yes. Thank you.
Your presentation, Mr. Karyawan.
Yes. I will share screen at first.
Okay, Mr. Karyawan, time is yours.
Okay. Thank you. It is okay?
Yes, it's okay. Maybe you
Yes. Sorry.
Okay, can you full
can
screen?
enlarge.
Yes. In the most right.
Can you enlarge, Mr. Karyawan? Yeah.
Like this?
Okay.
Yes.
Thank
Yes,
you.
you can start from.
Yeah. Okay. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. I will do present that the investigation of separation of effect of the catamaran floater resistant. That is a floater resistant. Floater itself is based on we will use with the aircraft and 19 amphibious. Okay, I'm a my name Karyawan and I work in BRIN. What is this? I don't know in BRIN. Wait a minute. And then this paper is one of requirement for my doctoral student. Okay. Next. This is in introduction. Were so many countries that geographically defined as Indonesia. This is need. Transportation across the island is important. Floatplane is an amphibious type of seaplane that wait a minute. Right. Floatplane is an amphibious type of seaplane that is equipped with submerged pontoon underneath their fuselage. This is Ali Frananda said like this. Thus, the floatplane is one of solution to travel between islands more quickly than ship. The study of floatplane still developing up to now. Floater resistant affected by floater of Freleng, that is a Sulisetiono, said like this, that according to study conducted by Januar, catamaran hulls small resistant force by adjusting the distance ratio between hull. The most method to calculate the predict the ship resistance were Savitsky and slender body. High-speed marine vehicle was given with discussion of including spray resistance using Savitsky whisker spray drag formulation. The result of the Savitsky method were relative compared to towing tank. This is wait a minute. The result of Savitsky method were relative compared to the towing tank test, Bartorello and Oliveiro. Although the Savitsky method were less accurate compared to Rand's method. It is Kasi write it like this. The use of slender hull from based on slender body method, the fine hull configuration provide less wave making resistance at high speed. The sun is it like this. The application of linear cylinder body to numerical method to have resistance problem have a widespread since this method can provide fast, accurate solution for the cylinder body types. Development to the original method, the researchers such as Michael, Wigley, and Ecker have been made, and this method can now apply to a wide range of hull from. From the explanation above, we need increasing efficiency by reducing the floater resistance was very important to study. This paper, conspiration effect of catamaran floater resistance using Savitsky and slender body. Method is a catamaran floater model. The floater arranged with catamaran configuration with one of hull alignment like this, longitudinal with other. This is a base of a Samsuar, Sayuti Samsuar conducted like this. And then this use the new what is this Cremona frame that we can change the trim from this point. The design and simulation of the catamaran floater model were used AutoCAD and Makassar software. This is a table that is a parameter. The symbol existing model is a length 9.8, and then the new is a 9.4. It is and then resistance characteristic, because it's different of the length, and the floater separation is also different. 3.9 meters, 4.2 meters, and 4.8 meters. That is a resistance characteristic is 0.41 and 0.42, 45 and 0.51. This is a plan, that is shear plan, breed plan, and body plan. Safety key methods. Resistance, the surface of the planning hull. The calculation using the safety numerical method, the total hydrostatic resistance of the planning hull consists the resistance force that occurs due to the resistance force acting normally on the sloping bottom, and the viscosity resistance force acting tangentially to both the bottom area and spray area. And then the fluid without friction, the tangential force is 0. Then the trim angle, displacement charge, and normal force based on resistance component can be written like this. Then the resistance, the viscosity resistance, dF, acting tangential to the bottom. Then the total resistance D can be calculated by formula like this. Then even in dF, this is a resistance component is for the equation 2 can be calculated, but it's like this. This formula 3, number 3. This is a other method. Method is a slender body. Slender body. Slender body approach was applied to the estimate of monohull and multi-hull resistance when the ratio between the ship length and breadth was considerable like this. Slender body method. Wait a minute. It was based on part course and use a fundamental by Michael that calculate wave resistance by Froth number 1. The resistance of the hull thin side is formulated by number 4, where number 5 is calculating like this. Next, approach determines the wave resistance by calculation. The energy wave is water surface is function of the speed ship speed. The program at the viscous resistance component, the total resistance calculation by using the coefficient of friction coefficient calculation method, and certain the factor simplification. The line of ITTC 1957 correlation depicted in equation is commonly used in calculate friction resistance like this in equation number 6. Next, next is the result and discussion. Hydrostatic of catamaran. This is parameter of the models. We use the existing and then the catamaran.
Sorry, Mr. Karya.
Yes.
Your time only 2 minutes left because every presenter only have 10 minutes for presentation. Thank you.
Okay. Yes. Thank you. Sorry. This is a picture for models and trim the 2 degrees, and this table, and based on the table, it seemed like hydrostatic calculation axis modified catamaran floater, so that was a significant difference in draft around 20% and wet surface area in around 28, and block coefficient is like this. And this is resistance using a Maxov at speed around 10, which is a floater catamaran type is 9.4. This is a ROS like this, and resistance characteristic is the slightly resistance is 0.5 0.445 to 0.51. And this also that is a flow turbulent behind the float. This is very wide. This is better, and this is 9.4 meter with around 19 knots. This is a picture. This is a zero characteristic. Resistance characteristic is based on the 0.45. And this we using the displacement from displacement to pre-planning with Saviski, and pre-planning to planning using a cylinder body. It's like it's different. The figure is said to be changed in the resistance pattern, and starter speed then 6 knot around here. Okay, this is a towing tank. This is towing tank bilang si Brin. The dimension of towing tank, length of 230 around 35, and
Sorry,
width
Mr. Karyawan,
11.
your time is
Yes.
up. Sorry.
Okay. Sorry. Okay. Yes.
For your presentation,
Yes.
maybe we
Thank
can
you.
discuss in discussion section.
Okay.
Okay, right.
Okay.
Okay, I will go to move to the. Is there any question in the room chat, Mr. Fari? No. Okay, maybe we can move to the. Is there any question?
The camera to the presenter, please.
Yeah, the camera, Mr. Digi. No. I mean this camera.
Yeah. Pak Karyawan, we should know him.
Yeah.
He's not a ghost.
Yeah.
Okay, Pak Karyawan, please show up you. So we are here know you.
Can you turn on your
work is very interesting.
Yeah. Wait a minute, Pak.
Yeah.
Okay.
Yeah.
Okay, thank you, Pak Karyawan. So you are now in your office at BRIN Jakarta, or?
Yes, BRIN Jakarta. I work in low speed Indonesian tunnel in Serpong.
In Serpong, yeah.
Yes.
So, well, the next question actually, why do you use a towing tank, not a wind tunnel? So you can answer later.
Yeah.
The problem is with the catamaran configuration. There are 2 points, I think. One with the separation between the hull, and the other one actually with the geometry itself, the type of the hull. Which one actually you consider more to give less resistance? Because you only use one type of hull, and then you separate between the two hulls to give you the lowest resistance. Yeah. Which one actually you consider? I think, in my opinion, with my experience, you should consider with the type of geometry as well, and then to give you the optimum low resistance. Okay, thank you, Pak Karyawan.
Yes, Pak. It's a good question. Now is still what is to development. development of the type of pontoon itself. The type is around a lot of with what is this length? First is 11.8 and then 9.8 and then now is 9.4. The 9.4 itself is have a four type with the stern is like this. What is this? Small in the back, and then stern is high. What is from front to step hull, and then a middle night. This is all have a calculated by CFD at first. Like that.
Thank you. Do you build the geometry by your own or use a standard like say NPL, maybe Series 64 and so on? Because you need your work.
Yeah. We design by group, by my group, and then myself with my design is using a hull configured by Bezier. What is this? Bezier for formulation.
So actually you use the geometry developed at RIN. Okay, not the standard model. Okay, it is a good point, I believe. So you should validate then between the experiment and then the numerical or CFD, and later you try to compare with a similar model to make sure that your design or your idea is of great innovation, Pak Karyawan.
Yeah, Pak. Jadi this is type of 9.8 is number 9 of the what is this 1 and 4 from LBDP, and then also we buy from other country the floater itself, 2 type, and then the simulation and the towing tank. The 9.8 is better than 8 before, and then after that we make shorter 9.4, and then at the 9.4 type we make around 6, but with simulation we just choice just only 2 type selected, Pak.
Okay, thank you, Pak Karyawan.
Thank you, Pak.
Thank you, Prof. Vikap, your suggestion. Thank you.
Thank you. I've stolen the microphone. My name is Martin Reynoldson. I have 2 questions for you. The first one, I don't understand how the Savitsky method shows the effect of the separation. You presented results with the Savitsky method, and you showed that, if I understood correctly, the separation has an effect. But my knowledge of the Savitsky method, I don't see how it can take into account the separation. So perhaps you have some modification to the Savitsky method. And the other question I have for you, maybe you didn't get to it in your presentation, but you clearly have done model experiment because we saw a video of it. So have you compared your results? A little bit like Professor Katut said, you need to validate the results. But you've done a model experiment, so can we see the results compared to the theory?
Yeah. At first we just did the CFD calculated, and then we compare with the existing model. The existing model itself, we have some data. We now we start to develop the existing model to the new model is length of 9.4 meters. At that time, now still calculate, and then we have also prepared the model for wind tunnel and also model in towing tank. Maybe, yeah, maybe around next year we started to experimental like this. Sorry.
Is it clear, Professor Renelson? Okay.
Professor.
Because time is already up. Thank you, Mr. Kayan, for your presentation. And I think we can move to the next presenter. Thank you, Mr. Karyawan, for your time.
Thank you.
And give me the applause to Mr. Karyawan. Okay, the next presentation is Mr. Rahmat Indra Cahyo and Mr. Arif Fadilah with title of Study on Design of Hospital Ships for Disaster in the Region of East Indonesia. Is there any Mr. Rahmat Indra Cahyo? He said that. Okay.
Correct. Is this your presentation? I think it's not. Is it correct? Is this one?
Oh, and one again, I forget for another information that there's some signature in the paper. So who participant who joins in here, please don't forget to sign your name in front of my table. Because lately I forget about it. So sorry. Is it okay, Mr. Fahri?
Please wait a minute. There's a technical problem.
Oh, okay. Maybe we can wait 3 or 5 minutes. Okay. The design of hospital ships for disaster in the East Indonesia. Study on design of his hospital. Yeah,
Yes. Mr. Rahmat Indra.
There is some technical problem. Maybe we wait 3 to 5 minutes, sir.
Yes.
Yeah, di situ. Ya, sit. You need the two microphone. Enough. Okay, Mr. Rahmat Indra, please start your presentation.
Yeah. Before we start, I'm so sorry to technical problem, and we can start. We will presentation with design of hospital ship for disaster in the region of ISIP.
Next. Background. Geologically, and Indonesia is located between three active tectonic plates, namely the Indonesia-Australian plates, the Eurasian plates, and the Pacific plates. This result in Indonesia frequently experiencing natural phenomena in the form of disasters such as earthquakes and volcanic eruption. This situation present Indonesia with the threat of disaster that could occur at any time, as shown by the maps of distribution of volcanoes in Indonesia. Next. Shipping route to Sorong, 182.55 nautical miles. Next. Purpose. Know the readiness of Eastern Indonesia region. Faculty if a distortion occurs. Calculate the bed capacity on design hospital ship. Design the layout and equipment of the hospital ship according to needs. Design a hospital ship with optimal size. Calculate the resistance of the hospital ship to determine propulsion power. Calculate the stability of the hospital ship according to applicable criteria. Next, this dimension of hospital ship. LOA 72 meters, LWL 1969 meters, breadth 16 meters, height 6 meters, draft 3.5 meters, freeboard 2.5 meters, coefficient block 0.578, coefficient midship 0.872, coefficient water lines 0.80, coefficient prismatic 0.674. Velocity 18 knots. Crew and medic crew 100 to 29%. Next, this is the launch plan. Next, the result resistant, speed knot 16, 17, 18, and 19. Next, main engine Myanmar type 6-8Y 22 AW, cylinder 6. Next, stability condition 1 and 2. Next, stability condition 3 and 4. Next. Ship equipment. This is the 3D rooms of hospital ship. Next. Ship equipment hospital ship. Next. 3D hospital overall. Next. Next. Conclusion from the result of resistance analysis using MaxSurf software, the hospital ship has a resistance at surface speed of 18 knots of 307.2 kilonewton with the required power of the 2018 2844.98 kilowatt. From the result of the stability analysis using MaxSurf software, all conditions met the IMO, and we error criteria, but in condition 2 and 4, the propellers didn't sink, so the ballast tank was filled to sink the propeller. From the result of the analysis from the readiness of facilities in the Eastern Indonesia region in the event of a disaster, the Eastern Indonesia region doesn't yet have preparedness when the disaster occurs in the health faculty or medical personnel. So a hospital ship is needed to help the Eastern Indonesia region in dealing with disaster. Thank you.
Please. Okay, thank you, Mr. Rahmat Indra Cahyano and Mrs. Arif. Go ahead. Oh, Mrs. Natasha, I'm so sorry. Okay. I would like to go to the Q&A sections. Is there any? Okay, Mrs.
Thank you. This is a interesting lesson, but my question is, what is the consideration or the method to determine the dimension of the hospital ship? And then the second question is, what is the meaning stability condition 1, 2, 3, and 4 mentioned in the presentation? Okay, thank you.
Okay, thank you.
Okay, thank you for the question. And for the one question, I will answer. For the method for shipping it to ship hull design, we use compression method. Compression ship method. Okay. We use two or three ship design for comparing my design. And question 2. For the condition 1 to 4, the ship, this condition 1, 2, 3, or 4 is considering ship with condition full tank or full equipment and full person. This is for condition 1, ship.
Mr. Diki, can you help me to show the presentation, please? Test. We can move to the stability 1 to 4. I think
For
in
stability result.
page 9. Yeah.
Okay. So for condition 1, ship is condition light ship. Sorry. For condition 4, ship is condition lightweight or light ship. And for condition 1, ship is condition full tank or full equipment and full person. And for condition 2, water ballast is full, but person is not full. Is enough to ini? It's clear.
Nice. Is enough? Is okay. Okay, we can move to Mr. Rika.
Okay, thank you very much. Interesting topic. Can we go to the conclusion, please? There was this condition. On the conclusion, there was these conditions where where your propeller is not immersed fully. Okay. Condition 2 and condition 4, it says here propeller did not sink. You mean it's not fully immersed, isn't it? Yeah. So ballast tank was full, correct? Number 2. In condition 2 and 4, propeller did not sink. So ballast tank was filled to sink the propeller. This is full ballast. Full ballast.
Full ballast in condition 2 to purpose because propeller did not sink.
Yeah. But
the ballast tank fill the water.
Yeah, but what condition is this? I mean, surely from your travel between Jakarta to Sorong, for example, Sorong, was it? What conditions could cause this event? Because if you goes to Jakarta to Sorong with fully medical equipment, fully medical person, this condition does not met. It does not. It will not occur. Is it correct or not?
Jadi for this condition and condition 2, we use water ballast and when the ship is not carry person.
You mean not carry all the medical stuff? Not carry person meaning what?
Person when victim.
Oh, okay. Go ahead. Go on. So if it's not carrying any patient,
Jadi
this is still on okay. So it's not carrying patient. It's all medical stuff. So
it's only ship crew.
Yes.
And equipment.
Okay.
Not include victim.
Okay, so which means that, for example, if there is a victim in Sorong, for example, so you would travel from Jakarta to Sorong with ballast condition.
Yes.
All the way to Sorong with ballast condition.
Yes.
Yeah, but you have a. Did you also consider that you have a full tank of fuel in your tank? Is it?
No. If for condition 2, when we go from Jakarta to Sorong, the fuel is full.
Yes.
And
still not enough to submerge the propeller. Still not enough because you said so.
No, but in when we use full water ballast tank.
Yes.
When in condition 3.
Condition.
When condition 4. When condition 4. When the ship condition light ship and lightweight.
Yeah, but it's not happening, isn't it? Because it's never happened. Because you will sail from Jakarta to Sorong with medical staff, with full equipment, but no patient. This is condition 2, yes?
Yes.
So meaning from Jakarta to Sorong, you would have ship with full ballasted tank. Correct or not? Correct. Yeah. Because there is no patient yet, correct?
Oh. So for the condition 2,
yes.
Is when we go from Jakarta to Sorong, the fuel is full.
Yes.
But when ship go, fuel when use and reduce.
Okay. So
reduce.
Yeah. So then is the time when you need to fill your ballast. Oh, okay. Interesting. Okay.
Have I time for a quick question?
Yeah, maybe 2 minutes.
Very, very quick.
Okay.
I'm just asking a question regarding the design. Was the draft an important consideration because you need to go into particular ports? And do you need to carry boats to access people in emergency? Or can you always come alongside, like you showed a nice picture of the ship alongside going into the dock, into the pier? But if there's been an earthquake, that might not exist. So do you have boats in order to take patients backwards and forwards? By the way, I would call them patients, not
Small
victims.
Oh, yes.
You have no image maybe to explain
3D design.
Is that general arrangement or okay?
In our design, we use emergency boat for port side and starboard side.
There's a rescue boat.
Yeah.
You mean? But what about how do you get the patients? If you've got 2,000 patients on the shore, how do you get them to the ship? The rescue boat would not be enough to carry 2,000 patients.
And for the shore patient, this ship will carry victim for shore when not from the sea.
Oh, but the patients, the people who are survivors are on the shore.
Yeah.
And presumably if there's been an earthquake, there is no infrastructure on the shore. So you have to get them from the shore to the ship.
Oh, we use emergency ladder or something. In 3D design, we draw with emergency ladder. Please 3D design. We use construction of this to carry patient from shore to ship.
So this belongs to the ship?
Yes.
I understand.
Okay, thank you. I think that's because a lot of time consuming extra. So the next part is thank you, Mr. Rahmat Indra Cahyo. You can go back to your seats. It's
that's all.
like
Thank you.
The next part, we have some coffee breaks, maybe 10, 5 minutes, 10 minutes, and to recover our stamina. And we come back again in here. And we have 4 presenter left. So I hope we can again after coffee break. So please to the next room for participant and professor.
Uh, 15 minutes. 15 minutes. 15 minutes.
Test. Okay, shall we start for the next presenter? It's from paper ID number 27 with the title Fatty Crack Growth on Ship Polyurethane Steel Sandwich Plate. With the presenter or the author is Mr. Hussein Shahab, Mr. Ahmad Zubaidi, Mr. Rizky Chandra Ariesta, Mr. Muhammad Nurul Misbah, Mr. Septia Hardi Sujianti, Mr. Doni Setiawan, and Mr. Vicky Kofi Azari. Okay. Is this presenter correct? Okay. Thank you. Please start.
Okay, thank you for the time already provided for me. First of all, good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. I'm here to present our research, not just to present, but to discuss with all of you about fatty crack growth on ship polyurethane steel sandwich plate, which represented Institut Teknologi Sepuluh Nopember, basically the construction ship laboratory. Next. Okay, first of all, the idea of the study that we conduct is come from the interest of us researching about the implementation of sandwich structure to ship construction, which from some of the previous research already carried out, found that it can give weight reduction, increased strength, vibration damping, and protection against fire to the construction of the ships. So the main thing is that we want to convert the conventional construction of the ship of the traditional materials such as steel to sandwich plate as the construction, which in this case we implemented polyurethane steel material. We will discuss this furthermore after this. But in this focus of the study, we study more of the fracture behavior of it, mainly the crack behavior, which we aim to understand the behavior of sandwich panel during crack propagation. So we know how to treat it and to optimally use it in the ship structures. As we see this concept already proposed by Zenkert in 2009. So to research it from the local point for the material, and we could study it to the panel, and then we go to its impact to the structure of the ship. Next. So as I already said before, we aim to learn to understand about the crack growth of the space of the material, and in this case we applied the material to a tanker ship with this particular dimension, which already shown in the screen. The study involved experiment procedure, which the result of the experiment will be conducted regression analysis, which we will talk. So this experiment analysis will be carried out to be applied to Paris Erdogan law approach. We will talk about it later. And then from the Paris law, we will get the coefficient, which will be the base of the fatigue law prediction. Fatigue crack growth prediction. So we will know how the crack growth and its fatigue impact to the structure. Next. So here's some detail of the material and the structure. Here's some illustration of it. So we use steel, polyurethane, elastomer, and steel again, the hybrid sandwich material, which the mechanical properties already shown in the screen. And for this study, we use 3 variations to find out the detail of the material. We varied the material on the face plate thickness. So we use 4, 5, and 6 on both top face and bottom plate. So the interface will have the different thickness, so we will know the behavior on the different types of the structure. Next. And as I said, as the basis of the study, we use the approach from Paris Erdogan, Paris law. In here we use it so we could learn the behavior of the crack growth, mainly in a scale like this. So in this chart, really shown how the crack really will behave. And the most important point in here is the region 2, which show the pace where the crack propagate. And in this region, we will use the regression line, which will be calculated. It can be using software, of course, and we will obtain the coefficient, which is shown in the equation right here, coefficient C and M. So we could learn about the behavior of the crack growth in the material. Next. And for the fatigue approach itself, this is the approach that we use. So we use the Paris law equation, implemented it in the calculation, so we could calculate the cycle prediction. So we could see the how the fatigue will propagate cycle by cycle, and also we could predict the time of the crack from the first initial crack to the final size of the crack. Next. So in this study, we use this experiment, ISTMD 5528 guidelines. We use it for the interlaminar mode 1 fracture. So from this equation, as I said, we determine the Paris law coefficient from the graphic result, and then we implement it to the fatigue afterwards. So, and in here, as the fracture value, we calculated using the modified beam theory, which provided in the ISTM procedure, which use the load and the size of the specimen, and also, of course, the fracture rate. So the size of the crack and also the width of the the surface ratio. Continue. Next. Okay. And here is shown the result of the experiment that we already put into the graphic. So this is only the propagation pace. So we use this regression line to obtain the coefficient. This is not the initial crack. I put an error in here. It's supposed to say the thickness of the plate. So the variation, we use 3 variation, 4, 5, and 6. And it produces regression above 0.85. So I believe it's good for the result itself to be obtained. And next. This is interesting to show. It doesn't impact the Paris law result, but we can see that maybe it's too small. The one below is 4 millimeter, and simultaneously it's 4, 5, and 6. So as the plate getting more thicker, the fracture toughness is become bigger. The value is become bigger. So that's an interesting thing that we found from the experiment that I think is unique to be shown in this presentation. And next. So here the coefficient that we obtain. So we see that the coefficient of the M is close, but the C is different from each other. So we can conclude that for each variation, it needed to be calculated each Paris law for the analysis. But for this study, we choose to use the average to predict the fatigue, to analyze the fatigue. So we focus more on the understand the method in the study. So we use the average. The C coefficient is 1.68. And the M coefficient is 0.56. 0.56. Next. Okay, and after we obtain the Paris law coefficient, now we put it on the fatigue approach that I already shown before. And here are the results. So the crack propagate fast on the early phase of the propagation, but it's getting slower at the third point is 277 days of its propagation. So it's interesting. It's also similar to what Paris already proposed about the propagation, which it will be slower as it's getting closer to its end of the crack, something like that. And for the calculation that we calculate, the maximum time to reach the maximum crack length is 344.94. So need to be known also that the crack happen in the core, so it's the polyurethane that have the crack. So the time is not as long as the steel could hold on the crack itself. So because generally steel can hold like so many years to produce the crack, to propagate the crack, because it's fracture toughness. Next, we also put some chart on the relation between stress intensity factor. The first one
sorry,
is
Mr. Sahab, your time is only 1 minute. Okay.
okay.
Thank you.
It's kind of close to the end anyway. So the first one is the relation with the crack length. So the stress intensity factor, although it looks not that much linear, but it's keep increasing simultaneously to the maximum point. And so we could conclude that as the crack length get bigger, the stress intensity factor keep getting bigger also. And if we look at the relation between the stress intensity factor and the crack growth rate, it's shown that like I said before, it's slower. The stress intensity factor at the start of the crack is not that big, but it's getting bigger at the end of the crack. But it's not as the similar trend as the crack length. So if we compare it to the red, it's shown like this. Next. So here's some conclusion of that. We obtained the Paris law. Also, we obtained the crack ground behavior of it. And next, because we have not too much time, I just want to tell next. Sorry. This is one part of the research that we do. So the bigger picture is that we want to conduct analysis on the structure of the ship. So we
sorry,
already
Mr.
conducted.
Hussein.
We just want to get this done.
Okay.
Just short.
Please, 1 minute. Okay.
So we already reached the panel analysis. So we want to research the crack growth on the panel, and then we want to know the stress reduction. That's what we are learning in our research in the lab. So that's just a picture. I think it's interesting, and we really use this Paris law to simulate the crack growth. We focus on it. So that's all from me. I hope I could get a lot of insight from the discussion, as I'm just a student anyway. We all always be a student. So yeah, I'm excited to learn from the professor and doctors in here. Thank you.
Thank you, Mr. Sahab. So I will open this Q&A section. I think there is no question from the online chat. Is it correct, Mr. Fahri? There is no question right in the online. No? Okay. I will move to in this audience. Is there any question? Maybe Miss yeah. Both of you.
Thank you, Mr. Moderator. Thank you for your interesting material, Mr. Hussein Sahab. Okay, the first one, I want to know about your result for this research. When is the material become thick? So the fatigue becomes small or big? The second one is, what do you load to use? Calculate the fatigue analysis. Thank you.
Sorry, can you repeat the first question?
When is the material become thick? So the fatigue become large or become small? Thank you.
Okay, maybe we can show the slide. We can see the material properties. So the first one is interesting, and of course it should be different, because as we calculate the Paris law anyway, it's different. So it should generate the different behavior. But in this study, we didn't learn it. we just take the average for these three variation and simulate it to the fatigue approach, analysis approach. So we are sorry that we cannot provide the answer for that, but it's an interesting topic. Of course, there will be another research for it, at least focusing on this material. And for the load itself, we use the Paris law to simulate the speed, so the correct growth rate. So it is the assumption that we use. So we didn't use the exact load from the experiment. So the experiment itself, we only use the result to calculate the Paris law. So we don't need to use the load anymore because it's already illustrate the correct growth. As we know, the Paris law equation already shown how the correct growth, how it behaves in its pace and position. So we don't need the load on this approach. Different from the numerical analysis maybe, because of course we will simulate it with load, mainly the ship original load, maybe the hydrodynamic, or maybe wave and stuff. Maybe wave will produce a bigger load to make the crack will grow. Maybe that's all. I hope that answers your question.
Okay. On the your one. Yes.
Thank you. My question is, if we look at the experimental picture show it on the slide, the damage is feel of faceplate from the polyurethane core. My question is, where is the initial crack mentioned, and how to determine the length of initial crack?
I'm sorry. Can I know the last question again?
How to make the initial crack at the position, because I think at the position is the damage is occur at the adhesive, not at polyurethane core.
Maybe we can see the slide again in the page 4. So in this study, we use we put the initial crack on the top of the specimen, the top of the sandwich core. We didn't put the variation of the position of the crack, but it's of course will be interesting if you learn what the impact of the position to the material. Next, sorry, bukan yang itu ternyata salah. Next. We want to see the specimen. Okay, so here the initial crack. Maybe it's really small, but we can see that there are different in here. So we put the initial crack on the top of the specimen. In this experiment, it's the phenomena happen is crack debonding. So the core debond from the plate, and it's debond, and it will of course decrease the strength. That's what we want to analyze. But besides if we put it on the top, we can put it on the middle here. It will be more interesting, of course, because we can see the crack grow in the middle of the core. And if we can move the slide again, page 2 maybe. Okay, I didn't talk much about this, but if we put it on the top of the core, but there are some possibility that this pattern of crack will happen. In the experiment, it actually interest to see this phenomena, but in this paper we didn't put yet, and this one is happen in composite, and in polyurethane elastomer. I believe, of course, there will be a different behavior. So to analyze the position of the initial crack, of course, will be an interesting topic. And for the next of course, we could analyze it more. Maybe that's all from me. Let's answer the question. Yes, for this study, it's only put in the interface. Yes.
Is it clear?
And also, I'm sorry. Sorry, I'm really sorry. The size of the initial crack, of course, will give a different impact. Okay, and it should be analyzed.
We need to miss Theo to
the topic of your presentation is very exciting and also at the same time thought-provoking in the sense that, to my understanding, the usage of another material at the core is supposed to reduce the usage of non-renewable materials, namely steel. So my question is, the choice of material for the core, what are the considerations for choosing polyurethane, and what are actually the reasons to choose polyurethane? That's the first questions. I think I should restrict to 2 questions. The second one is, please show the last page of the slide. Where the further research, yes, it is a vertical part of a hull, right? And it is a bit challenging. And suppose when you I'm thinking of the huge challenge to use this composite, how we call it, this material for a vertical part of a ship, of a hull, where other constructions materials of steel to be welded there. It would be a bit less challenging if we use, suppose this the result of the test would be okay later on. Would it be less challenging if you use this new material for horizontal part of a hull? So not the hull, but the deck and things like that. Yeah. So there is no such a huge requirements to support loads in such as like cantilever, but simply as a plate with a minimum requirements to weld or to be connected to others. That's my thought. Okay, thank you.
Thank you so much for the question, Mr. Setio. So for the material first, firstly, we conducted this study on sandwich as we on the from construction ship laboratory. Professor Zubet, our supervisor, our professor in the laboratory, has wonderfully talked a lot of sandwich. So he already study a lot of material variation in sandwich, such as honeycomb, composite, and using some natural materials such as bamboo fiber and etc. And in this, in case of polyurethane, it's not the first kind of sandwich that used in the construction, such as house and building and etc. Because this construction already used in different place of focus, something like that. So we learned that this material in the applications such as building and airplane and etc. Has some advantage, and mainly our focus is about the how it lighten it's reduce the weight of the construction. That's our focus on the of the polyurethane. So we see the reference on other construction kind of construction, and we try to apply it on ship constructions. So that's the background of why we use this material.
So the consideration is that the material is light.
Yeah, lighter, and as the research already conduct anyway, it's still produce the same and even stronger weight, stronger construction to at encountering the load of the ship. So it's already conducted some study before, and in my case, it's already focusing on the fracture because we already study the advantage enough.
To illustrate the case for, let's say, 10 millimeter plate, steel plate, by using sandwich, how thick the new material will be? Listen.
In fact, it will be too thick to use the 10 millimeter plate. So I'm sorry, from the approach that we use to convert the conventional structure, we use the rules from load register. So there's already the rules. So we use the modulus of the ship construction.
Yeah, understand.
Yeah.
But what I mean is actually to have a better view about the material.
Yes. Okay.
10 millimeter steel plate. How much or how thick will it be in sandwich material?
Okay. In sandwich material, in fact, if we have the example of the steel 10 millimeter, we could substitute it to like 4 millimeter top and bottom of the sandwich. So, and then in the at the core we could use in this case polyurethane to around like 18 to 20 millimeters, something like that. So it minimizes the usement of the steel, and of course it will reduce the weight because polyurethane is much lighter than steel.
Okay. So the material becomes lighter, but the dimension, the thickness will be around 3 times thicker. Is it correct?
Yes. It will be thicker, but of course it's the different materials. And I will advance to the second question. So the second question is, I'm sorry, can I know the detail of the question again?
Actually, the second question is about this. Do you think the new material, the sandwich material, more appropriate for which part of the hull of the ship? Is it more vertical or somewhere else?
Okay. So we are also already conducted some research on ship construction. If you say horizontally, we already conducted on deck and on the inner bottom. So of course, in this place, it's the focus is to reduce the weight, of course, because we use tanker in this case. The load of the construction receive is not as big as what the bottom or the side of the ship will encounter. So so if you ask what's better, I believe it's depend on the case, because of course we could apply it on every part of the ship, but as we analyze, there's a possibility of fracture on the side. That's the disadvantage of this material, of course, and the weight from the side ship side of whole, it's bigger. So if you ask, it might be better to use it horizontally. But of course, I still say, Mike, assistant, maybe it will it needs more research for that if we want to compare it.
Thank you.
Yeah. Thank you also, Mr. Satyo.
Thank you for Mr. Shahab. Is enough for your turn. And we can move to the next presentations.
I will say thank you to everyone. I hope I didn't kill the caffeine that you already drink. Okay. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Okay, we can move on to the next presentation. Is Mr. I. Ketut Arya Priyautama, Mr. Ahmad Nasiruddin, Mr. Adi Nugroho Yulianto, Mr. Sutyo, and Mr. Bagyo Swasono. With the title is Comparative Study on the Resistance Characteristics between Dharma Sub-Off and U-209/140 submarines. For the presenters, time is yours.
Okay, thank you. Good afternoon, everybody. I'm say thank you to ICSOT committee and that I have opportunity to come here to be present my research study about the comparative study on the resistance characteristics between Dharma Sub-Off and U-209. And I'm RD from ITS Surabaya. Please next. In this presentation, I will start about the introductions, methods, and then a result and discussion, and the end of the conclusion. Next. As we know that our country is 70% is the sea, so we need some technology to control about this area to protect our territory. And one of the technology that we must have about the submarine technology, as we know that Indonesia don't have more submarine, so this is a big opportunity for us to make a development in the submarine technology, then underwater and so on. Next. In this paper, I will compare between the DARPA and U-209, and this research aims to investigate the effect of geometry shape on resistance between both of these type of submarine. Next. I use numerical analysis with computational fluid dynamics. In this research, this is the preliminary stage for our research about the getting the resistance with the submarine. Usually, for the cheap way to get the resistance, we can use the CFD analysis or use the mathematical model. If we use in the experiment model, we need a little bit long time and high price to do it. Next. This is the main dimension between two type of submarine. Next. And then this is the general boundary condition to make in the CFD that this is true exactly to prevent the negative impact of black flow on the area boundary. So we must make sure that there is no big impact in this model of the CFD. As we know, if we use a computational model, there is some problem that we need the high technology for the hardware because it's a little bit time consuming to do computation if we have too many elements and so on. Next. This is about the convergence study. If we get the efficient element that we will do, it will be good for a time consuming in the computation process. Because if we have too many and the result is same, we can decide it where is the low element that we must use. Next. Next. In this study, we get the result in this non-dimensional. So we compare in the non-dimensional for fruit number and the resistance coefficient. From this study, generally for DARPA, we get 22.5% smaller than U209. Is indicated about the shape in the bow. Bow is different between DARPA and U209. Next. This is about the contour of flow area for both of the type of submarine. Next. Also, this is also about the flow around hull in the bow area for DARPA and U209. Next. So the numerical calculation to obtain resistance have been carried out, and we know that the DARPA get the lower resistance than U209. Bow shape and hull shape play an important role in the relation about the resistance, because the DARPA has maybe more slim, but in the bow area. Next. Because this is still a preliminary study, so we still have many works. Exactly, we must make verification about our numerical analysis, because we cannot believe about this calculation. This is just for preliminary. We must make verification for lab scale model, so we can use towing tank or use wind tunnel for viscous resistance. Also, we can compare with the other method for mid-cell theory or thin ship theory, so we can know about the wave resistance. Also, for viscous resistance, we can use wind tunnel, so we can compare and we can check about the numerical analysis by CFD, because still many error in the CFD. So if we can do about in the lab scale model, it will be make confident about the exact solution about the resistance. So we have planned in the next stage, maybe next year, to get more detail, and also the other type of submarine. As we know that we have many type like midget submarine, mini submarine, and then about the shape, about the albacore, and so on. So we will get more variation for the coefficient of resistance. Okay, next. I think this is for my presentation. If we have some question and suggestion for us, please let me know. Thank you.
Thank you very much, Mr. Adi, for your presentation. I will give the opportunity to the online section. Is there any question, Mr. Hari? I think no, right? Okay, so I will move on to the next. Yeah, maybe Professor Rinal first, and going to Professor Ika.
Thank you. Sorry for jumping ahead of you. Thank you very much. A very interesting presentation, and I look forward to a lot more work that you're doing in this area.
Yeah.
And I was very pleased to see you have the results non-dimensionalized, which all looks very good to me. But I have two questions. The first one is, it would be nice to know how much of the resistance was due to the wetted surface compared to due to the pressure resistance. Because it's quite clear that just looking at it, the 209 has got quite a lot of extra wetted surface for the same length. Because it's not round, it's got the casing and it's got everything else, and it's got a bigger sail as well. So a large part of that increased drag may simply be because of the increased wetted surface. And so it would be nice if you could present the skin friction drag and the pressure drag separately rather than just the total drag. So that's my first question. The second question is, I believe that you non-dimensionalized everything with respect to length, which makes very good sense, very good thing to do. But I would think I'd be right in saying that with the same length, the sub-off would have a lot smaller volume. So to be fair, to make the same equivalent for a designer, you should make the sub-off longer to get to so that it has the same volume. And then compare the real values, not non-dimensionalized with length. So, or maybe an alternative would be to non-dimensionalize with volume, because I think if you had the same volume on the two hulls, you might find sub-off actually had greater drag, because to get the same volume, it would need to have a lot greater wetted surface, because it would be a lot longer. I'm sorry, there's a long question.
Okay, thank you, Professor Renlison, for the first question. Yes, I agree that exactly the resistance in the total, there is viscous resistance and wave resistance, exactly. But this is, I give it the coefficient that the total. Exactly in my experience in 2013, I try to spirit about this viscous and wave. I use the wind tunnel. So wind tunnel just for viscous resistance. So, and then we can use for the total, we can use in the towing tank. So we can compare with viscous and the total. So we can get about the wave resistance. But the other,
but you're submerged, aren't you?
Yeah,
submerged. So no wave resistance.
Yeah, I know about this. There is some issue that if we there is three conditions in the submarine. This is when we operate in the surface area and then snorkeling. All the snorkeling, all the body also submerged, but there is still a wave. But in the fully submerged, there is some research before that the condition of the depth must be, if I'm not wrong, if 5 times of the length of the submarine. So we can say that this submarine is the fully submerged. So it is, but we just try to make that this is the fully submerged. So we don't do still in the snorkeling condition and the surface condition. So I say that I still have more work about this apart.
Sorry to interrupt. The results you gave are in the deep condition.
Yeah.
So in the deep condition, there's two components of resistance. One is skin friction, and the other is viscous pressure. So my suggestion is that if they are the same length, the 209 has greater wetted surface, so it is going to have greater skin friction. But if they are the same volume, then the sub-off would have to be longer, and it would have greater wetted surface, so it would have greater resistance.
Yeah. Of course, I agree with you. This is the comparison is not little bit not fair, because the length is one is 60 and the one is 100 more. So it's little bit not fair. If we compare with the same class, I think it will be still fair. So in the next step, we will find more the model of the submarine. So we will grouping about the length and the volume and the other thing.
Actually, I was going to ask the same first question. I've already responded. Yes, thank you.
The other question, maybe
Please, if you have any question or suggestion, or you want to make collaboration in the next state of the year, we are very welcome, because this still make a preliminary, so still many work that we must do, and we must develop for our country, that we must know about underwater technology. So please, if there is something. Yeah. 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 For quickly, we can use safety. Yeah. Yeah. In 2013, I used wind tunnel because, but this is we just know about the viscous friction and the pressure in the submerged condition, but we cannot use this result if there is submarine in the snorkeling and surface condition at the time. Yeah. 209 is good in the surface as snorkeling, but for DARPA, because this type is albacore, this is good for the deep, for the fully submerged. So because the structure is just like a meatball, fully around like this.
Okay. Is there any questions? Okay, maybe I will ask one question.
Yeah.
But it's okay. Yeah, it is a new knowledge for me. Also, thank you. My question is, what is the consideration that you use to choose two kind of that submarines, DARPA and also U-200 and so on?
Yeah.
And I want to know, is that two of the submarine is the Indonesian submarine? I mean the design is Indonesian submarine.
Okay.
Okay, two questions.
Okay, this two type of submarine is very popular. So I use this. So both of them is different function. For U209 is a specialist in the snorkeling and surface condition, but the DARPA is albacore type is good for the deep. Maybe it will be different mission in the military system. Yeah. And then the second.
Is that the Indonesian type of military?
Yeah. Hopefully for our Indonesian, we can make by our design with made with our territory, because we have some sea that very deep and shallow and the other thing. So this is our challenge exactly. So in the 2016 ITS with the Minister of Defense try to make about the mini submarine. Exactly, the small submarine is a midget, but we make a more smaller. For we call mini submarine is the length just 22 meter, So it will is already make about concept design for arrangement and anything, and also we do the resistance in the PPBT, and then we also make some pressure hull, because in the submarine the pressure hull room is a very important part at the time. Also about the battery, because when we do in the submerged condition, we just use a battery, so it's it's little bit quite difficult, because normally submarine use lead acid. Lead acid is but lead acid have some problem in the charging system. But now at that time I proposed about the lithium part. It is quite easy for charging, like our gadget. So when 50% we can charge again more again, and lead acid we cannot do that. But in the lithium, this is too lighter, very light, not bad. So it's will be problem. We need to sync our submarine, but we need more weight. So it's problem. We must use like a permanent ballast and so on at the time. So this is our challenge. If there is some people and student we want to collaboration about this project, please let me know, and we are very welcome.
Thank you, Mr. Ardi. Maybe there's no question more, right? Okay, maybe we can thank you, Mr. Ardi, for your presentation. And
Thank you.
please get applause for Mr. Ardi. And we can move to the next presentation. That is Mr. M. Iqbal.
No, next one.
Oh,
Number
okay.
33.
Okay. The next presentation is Mr. Cesar Alexander Glenna and Mr. Fahri Ayub, Mr. Muhammad Rafli Sukma, and Mrs. Vivin Sulistiawati, with title of Comparative Analysis of Ship Resistance Against Conventional Side Hull Trimaran with SWOT Side Hull. For the presenter, Mr. Cesar, am I correct? Yeah, please applause to Mr. Cesar. Yeah, for Mr. Cesar, time is yours.
Yes. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. First of all, I'm grateful to be here. And today I want to present my journal about comparative analysis of ship resistance against conventional side hull trimaran with SWOT side hull. First of all, we all know that Indonesia is a maritime country, and according to Directorate General Indonesia, in 2017, Indonesia has 20,507 ships, and at 2022, Indonesia has 99,700 ships. This is a massive increase in ships number. Such increase encourage innovation, such as small water plane area twin hull and trimaran. Trimaran is a hull that is a ship that consists of main hull and two balancing hull. Trimaran has many advantage, such as trimaran has a better stability because trimaran has two balancing hull. Trimaran has a faster speed than both monohull and catamaran has more expensive deck. Now about SWOT, small water plane area twin hull. SWOT is a double vessel that resemble torpedoes and are connected to deck by struts. Since the hull is far from the water surface, it experiences minimal wave interference. SWOT have one notable advantage, which is SWOT could minimize motion in turbulent waters. But SWOT is relatively costly compared to other alternatives. This is the geometry that we use in the journal. We use the conventional side hull trimaran model that we acquired from previous study, and we make a variety of it using SWOT side hull trimaran. Here is the hull parameters, and here is the geometry. In this research, we use ANSYS ISIM to analyze the resistance. In the boundary condition is made following the size of the original towing tank. Here is the mass convergence. In the mass convergence, we can see in the graphic that the force is keep decreasing until it reaches constancy at 1.9 million mesh. And then we use the 2 million to around 2 million mesh in this journal to calculate the resistance. Here is the result comparison between the conventional side hull trimaran and the SWOT trimaran side hull result data. Here is the total. Here is the total resistance coefficient. We can see from the graph that there's a notable difference in 0.1 Froude number and 0.5 Froude number. The CT is significantly decreasing in 0.5 Froude number to 0.7 Froude number. And in 0.8 Froude number, the CT is consistent. Here is the coefficient frictional resistance. We can see from the graph that the trimaran coaxial side hull has a lower frictional coefficient than the SWAT side hull. And here in the wave resistance coefficient, the SWAT side hull has a bigger coefficient than the conventional one, but the difference is not very significant. Here is also the viscosity resistance coefficient. It's the same as the wave resistance, which is not very significant. Here is the wave contour for the conventional side hull trimaran and the SWAT side hull trimaran. We can see here that the SWAT side hull has a better wave contour, have a more regular pattern than the conventional one. It's happened because the trimaran SWAT side hull has a more little water area than the conventional one. Here is the interference calculation. After we acquire the total resistance coefficient, we can calculate the interference calculation. Here is the graph that show that the SWAT side hull has a more constant interference than the conventional one. From the conclusion, we can get that each hull shape has its own up and down, and SWAT side hull have a better wave contour than the conventional side hull one. Thank you.
Okay, thank you, Mr. Cesar. Okay, I will move to the Q&A sections. Is there any want to ask a question? Professor?
Students first? No, you first.
You first.
You want to?
Yes, the second.
Okay. Thank you very much. Thank you very much. Very interesting concept. With trimarans, the longitudinal position of the side hull depends on the Froude number or the optimum, and you have the side hulls quite far back, which would be the case for a high-speed trimaran, which I'm sure you're aware of. The volume of the side hulls, normally the volume of the side hulls is dictated by damage stability considerations. Of course, when you've got a smaller waterplane area, that might change the damage stability considerations. So my question really is, do you have the same volume in the side hulls for the trimaran with the swath hulls as you do with the trimaran with the conventional hulls? Are you keeping the volume the same, or how are you? Because that will change the stability as well, because you've got smaller waterplane area. So what are you keeping constant?
Thanks for the question, Professor Martin. For this research, we just vary the shape and not the volume of the hull itself.
So the two side hulls are the same volume. The swath side hull and the conventional side hull are the same volume.
Yeah, same parameter, but just a different shape.
Thank you.
Is it clear, Professor? Okay. Okay, we move to the second question, Mr. Fajri.
Okay, thank you, Rafli, for the excellent presentation. I have only one question. Is there real application of trimaran with SWOT? Because I never see a real ship with trimaran with SWOT. Thank you.
Very excellent question, Mr. Fajri. Let me answer. As for trimaran with SWOT side hull itself, I also never seen one. And I hope with this research, there will be more trimaran ship with SWOT hull in the future.
Okay, thank you. I want to go to the next question. Okay, Mr.
Okay, thank you, the presenter. It is a very interesting work. At the conclusion, you said that there's a wave phenomena better in trimaran with swath type, but the result of the resistance plot look the same between the two configuration. Could you make clarify this? In which part actually the wave is better for the trimaran with SWOT type? Perhaps there's a picture or a plot you can show us.
I'm sorry. So the question is,
In the conclusion, you said that the wave, the wave structure is better for trimaran with SWOT hull, but when you show the trend of the resistance, almost the same. You said that.
Oh, yeah.
See, better wave contour.
Yeah, the wave contour itself is when we put the model on the answers, it is shown that the trimaran SWOT side hull has a better wave contour. The wave is more regular than the conventional side hull one.
But from this two picture looks the same. Perhaps you have to zoom that and compare to this result, it also look the same. And the trimaran with SWOT actually slightly bigger resistance in some part. But maybe this one could answer my question, because at lower fraud number, so the resistance of trimaran SWOT less than the conventional or standard one. Yes, please.
Just the resistance coefficient is non-dimensionalized by wetted surface.
Sorry, sir?
How do you non-dimensionalize the resistance coefficient? Is it by wetted surface?
Yes, sir.
Yes. So have the two hull forms got exactly the same wetted surface? Because the SWOT would usually have a larger wetted surface. So at a particular Freud number, just because the coefficient is lower, if the wetted surface is different, you can't necessarily make the comparison. Does that make sense? So how do the wetted surfaces compare?
I
don't know.
You understand? Yeah. Actually, when you calculate the CT, I believe you know the formula CT actually total resistance divided by half weighted surface V square.
Yeah.
So that's Professor Martin highlight that how do you use the weighted surface area for the both model or the both configuration.
For this, I don't know the answer for this question at this point, but I'll try to investigate the matters in the future.
Okay. Your conclusion could be correct, but you need to explore from the CFD visualization. That's the answer. It's somewhere there. Okay, thank you.
Yeah, thank you. Okay. Thank you, Mr. Ika, for the suggestion to Mr. Cesar. Because the time is already over, we can move to the last presentation. Oh, this is the last presentation. So I hope we can meet again tomorrow in sharing session day 2. Maybe that's all that I want to say. Is there any photo session, Mr. Fahri?
No,
Photo-
it's already done for day 1.
I mean, there is photo session.
Yes.
Okay.
There's photo.
Okay, we close with the photo sessions. All participants can move forward and we can there. Before that, I will close the 41 first. That's all. If I have mistakes, I'm so sorry. I hope we can meet again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Nggak bisa. Nggak bisa. Okay, we have a photo session for closing the day 1. Please, for every guest and participant can move to the front. We have a photo session for the day 1. Okay, please move to the front, everyone.
Pertanyaan titipan. Yang tadi pertanyaan titipan.
Okay, don't be shy. Just go to the front, everyone, for the closing day 1. Let's nanti keynote speaker diantar pakai Vios, tapi cuma 3. Ya, cuma 2. Saya nggak ngikut. Please. That's attention, please. Maybe for okay. Sorry, sir.
You have many friends. Everybody.
Cek. Pada Mas Anam.
Tes. Untuk yang bernama Mas Fatih.